TLB, but I think it is something that that we should, the royal we, that I think within the project we should try to find what we hope to do, and if there's funding that's needed from the foundation to help make that happen, then we can take it on. Yeah, I mean, I think in some cases we had one person in the FreeBSD community who was really engaged and sort of maintaining it, and then if they don't have time, as much time available, it just sort of fell by the wayside. And so, I think there's that may well be something that either we need to find someone else in the community or someone in the foundation to try and work with Coverity and sort of get that back into a good shape. Warner's got a question, John.
My question is simple. We've had a race between moving things to not be required root and adding building infrastructure that requires root. Figure requires root for all the jail and cool CFS operations. Are the notions for unprivileged builds that you have in your slides geared more towards adding the fundamental features so that we can use Poudriere without root but still use the cool features, because when you don't use them it gets really slow? Or is it to avoid using Poudriere to do building?
So I will say that so we sort of have the high level tasks that I listed on the slide, and then underneath those there's slightly more detailed subtasks, but it's really not very prescriptive at all about about exactly what we're going to do to achieve those goals. And so I very much don't want the takeaway here to be that we're going to do a whole bunch of work and we're going to say this is how it's going to be done. The goal really is to understand the problem and invest resources to solve it in the way that is right for the project. And so, I mean, I think from my personal perspective, I'm very much invested in being able to build release artifacts without requiring root. And so if for the source tree and ISO images and things, if we just assume packages come from somewhere and we don't really look too much into that, that process is fairly easy to do in a it's fairly easy to get to a place where release media is built without requiring root. If the answer is, how can we use Poudriere to build without needing root, and there's some work that needs to be done to be able to support that, and that's what everyone agrees on, then absolutely we can put resources behind making that happen. Colin? Yeah, so Colin pointed out that it's fairly easy to build one architecture. So basically build release media for one architecture directly without root, but the release engineering team's tools that build the whole set make use of ZFS and things like that. And yeah, absolutely, that's something that I think we can. That's certainly input into looking at what we can try and develop under this this process. And I mean, I think fundamentally, there's a lot of similarity between the issues there and Poudriere's use of ZFS and jails. Like there's a lot of sort of a lot of potential overlap and things to investigate there.
I wanted to say something like the relay, not running as a root. I think it just wasn't thought the course are built, but as nobody already, so I think you just need to hope for the, I guess, create long code stuff and that's it. It should be a easy project and quite fast if someone wants to look at the ideas of shell script.
Alan's got a question behind you there, John. Yeah, so I think that's one of the things, just sort of my personal take is that in FreeBSD, this is an impression I have, for quite some time, that we build a lot of great tools, we build a lot of great infrastructure, and we sometimes are not as good about kind of having prescriptive ways to use them. And so I think like that's a great comment, Alan, that I think if we just sort of, we can say like, we'll use this user to as part of our build process, and have the we'll assume, I think we can assume ZFS for the as sort of a requirement or a condition for some of the work that's going here, and build it out there. I'd like to talk to you a little bit later on about some of that as well. Alan's got another. Oh. Another question over here? I think Alan, do you have another question, Alan? Yeah. Yeah.
Do you have any more ideas about what you want to do for the software building materials?
So I think like we're really on a sort of, we have a high level view, I think, of what we're looking for, but we're really on a bit of an investigation and fact-finding mission at the moment to really understand what we want to do. So that is something I'm very interested in talking about and getting input on.
Like, are you thinking mostly for the base system, or being able to look at an existing system and the packages on it and be able to generate it?
So, I mean, I don't think we're looking so much at, I have an arbitrary system. I want to produce SBOMs for what's already here. But I think as the base system is definitely in scope, but I think also like looking at whether we can add support into to package to pass through SBOM information, or collate and collect it and produce output would be something of interest. John's bringing the mic over. And then we have two questions over here too, John. So
We did do this, and one of the issues we face, we do generate SBOM as part of our build. One of the things we noticed that we don't version our modules. We actually look at headers to extract the versions.
Mm-hmm.
So it would be good to kind of, in the base system, to actually add that support where we don't have to look at the finding where it's included. And for the code system, that would be good. But with the base system, there's some trickery we need to do.
Okay, yeah, I would be very interested in chatting with you about some of the specifics behind that.
My question is on the eBPF enablement for the FreeBSD. It is actually for the requirement if we want AXDP. So the XDP, Express Data Path. So a lot of customers in Azure, we have seen, they are very keen on using XDPs. Already PPTK is there, but they want XDP. So an XDP requires eBPF. So I had a chat with Royal Stone last year sometime,
project, but that never got completed.
Mm-hmm.
When I checked with Ryan, he told that it's quite a big task. So, being on this.
So I don't currently have any sort of planned or scoped work for eBPF support. I think that is something that I think in general, I think when information like that comes to the community, I think we definitely want to start in venues like this, sort of having discussions to find where the interest lies, and find more, all the people with similar goals and similar interest in it, and see about how see if we sort of as a community agree that this is something that we need to do, then look at funding or kicking off a project to make it happen. I agree. I think the Google Summer of Code project to sort of explore it was great for a student to be able to spend a little bit of time and investigate it. But I think it is something that if we decide it is important for us to do, then it's going to take a broader effort for the project to get a compelling and maintainable implementation. Any other questions? John? Back over here again.
One good question that is, I can see a lot of traction on the mails going on the last for FreeBSD. So,
Yeah.
the mails. Yeah. So, what is the plan actually? Because I can see a lot of the time customers, they are interested to know whether the kernel modules have got Rust compatibility or not. User space we already have got, but kernel modules I'm talking in drivers. So.
Yeah, so that's a great question, and I think that question is sort of somewhat more, it's the FreeBSD community that needs to set that direction. The foundation, we fund projects, and we will try to advance the project in ways that we feel are important through discussions with the community and whatnot. But I think in the case of sort of the policy on Rust in FreeBSD, we really need the source manager team, which we'll hear more about later today, or maybe it's tomorrow, and the core team to kind of or the core team to sort of establish that where we want to go there, and then with sort of an agreement within the community that is something we want to support. That's absolutely something that the foundation can then say, yes, we'll provide resources to make this happen. My perspective is I think there is a lot of value of being able to, especially for downstream consumers, be able to support Rust in the kernel in a consistent and officially upstream supported method. Even if I think there's no desire or plan to rewrite any existing portions of the kernel in Rust. But if a vendor had a network driver or something that was multi-platform and in Rust, I think we very much want to be able to accommodate that within FreeBSD.
I would just say, based on the mail that's come into the foundation and past discussions, my take is that, and I refer to what Brooks said in some discussions, I think it was at BSDCon, it's inevitable, it's going to happen, it's just how it's going to happen. You know, now that the line between the base system and not the base system is going to probably blur a little bit with package base, so there's different ways it can happen. I don't know when, but my take, if I looked at my crystal ball, I think it's going to happen one way or the other. It's just when and how.
Warner's got a... All right, and I think this will be the last question. I'm getting the hook.
The big problem with Rust, apart from nobody's done the build integration into the base, is that Rust has FreeBSD as like a tier 3 for most of the architectures that are interested in FreeBSD. So the question for the foundation is that something that you could work with the Rust Foundation to improve?
Yeah, so I mean, I think that kind of gets to the point I was making earlier that, if the FreeBSD community sort of officially decides that the FreeBSD project leadership decides that this is an avenue to explore, we can absolutely look at resources to make sure that Rust upstream has good CI for FreeBSD or whatever's outstanding, preventing us from moving up from tier 3. I think that is absolutely something the foundation can invest in as a result of that community decision or community process. All right, thank you. That's for the stream.
Yeah.
And then that,
Oh, this is not very easy to use. Okay. Sorry for the...
Set that up, then you have the root.
Okay.
And then
Let's get this.
This is Deb's clicker if you want.
No. I'm going to be fairly... Wait. That's not how it's supposed to work. Yeah, no, I don't. I'm trying to make this...
Presenter mode or something?
Yeah, but it's supposed to... It's not supposed to... Okay.
That's a PDF or is that
No, it's a slide,
it's
but I'm
under-
just trying to make it do... Oh, so I need to make it not mirror the screens, but instead...
yeah, I have two separate ones.
Yeah, but how
That's
do I do
probably
that?
a setting within macOS.
Yeah,
You have like
I don't
the
think
screen
I've done that
settings.
before. How do I do that?
And screen settings.
Where is that?
Here in the where the
In
ears
here?
are.
Yeah.
There should be some
Oh, okay.
way to change the display to not mirror. Is there a display section or just search in the search bar for it? Yeah, there you can say which one is the primary and which one is the secondary one.
Oh, okay.
Or go arrange and then you can shift those around. Yeah, they are mirrored there. And I think there's a way.
To mirror displays, hold Option mod to relocate, to rearrange displays, just drag them to the desired. Oh, okay.
But it's still mirrored after that,
Yeah.
right? And maybe it's a setting in one of those before.
Mirror. Stop mirroring.
Yeah, there we go.
Got it.
That's the one.
Yay.
Yeah, now it's changing. Okay,
Okay.
we're getting there.
Let's try
You
that.
you can go over a little bit. At this point, we're a little bit late
Yeah.
anyway. So
How's that?
yeah, and then you can drag it to the other screen. Here we go.
Drag it to the
Yeah,
other
better
screen.
one.
I have to look what I'm doing on this side.
That looks like it. Okay.
Well, I mean, it's close enough. I don't know how I make this.
But can you go in, if it's a browser, you go full screen from there?
Yeah, it is full screen. Well,
Yeah, this one.
that one.
On the right side, there's also a full screen. Like if you go way up, there's a setting.
I mean, it could stay like this.
Yeah,
I
that
mean,
works, I think.
Yeah. Okay. Hello? Yay! It worked. Finally got it. I haven't done a presentation in quite a long time, so presentations, talks, not so much. Welcome everyone, my name's Alice. I've met some of you, not all of you. I'm relatively new to working with BSDs of any kind, especially FreeBSD, which is the one I'm mostly working with at the moment. So I've come here to talk to you a little bit about a project called Chaos, which is another open source project, and how it helps open source communities to better understand the health and sustainability of their communities and of their projects through using metrics to better understand the projects. So before I get started, or let's get started, put your hand up if you contribute to an open source project. Keep your hand up if you contribute to 2 open source projects. 5? 10? Wow. Ed's got his hand up still. Put your hand up if one of your projects consumes another open source project. What if keep your hand up if it consumes more than 10 other open source projects? More than 100? More than 1,000? I'm counting all the way down, you know. All right. So this is a talk that hopefully should be of interest to you as users and contributors to open source projects. Let me see if I can just get this turned a little bit. Okay. So the focus of this presentation is on using metrics to improve project health and sustainability. Open source projects aren't static. They aren't healthy or not healthy, sustainable or not sustainable. One of the advantages of using open source is that we can work with these projects to improve health and sustainability, whether you're a practitioner, researcher, or something in between. So that's what I will focus on in this presentation. So I just wanted to start quickly by thanking some of the sponsors of the Chaos project, which includes the Alfred P. Sloan Foundation, the Linux Foundation, and the Ford Foundation. So I'll say a little bit about myself. My name's Alice Sowerby. I don't think it actually says that up there. It said it on the first slide. I'm from the UK. Sorry, that's the microphone. I'm British. I'm a freelancer. You can see some pictures of me up there. One, I'm wearing a lot of sparkling. I haven't done Strictly. This is my plan, first step in my plan to get famous enough to do Strictly. Then that picture at the bottom there is me in Chequers, which is the UK Prime Minister's country house. If you want to know why I was there, I've been there twice. Then you can come and ask me about that later. It's a little story. So in June, I started providing program management work for the FreeBSD Foundation, and I work part-time. I've been working in the B2B tech sector for over 15 years, and the places I've worked at range from developer tooling startups, so I kind of got in on the ground floor with containers, Also machine learning, tooling startups, and I also most recently was doing DevRel for Equinix on their Equinix Metal or free bare metal offering. Outside of the FreeBSD Foundation, I'm active in several open source projects, including, oh, that's not what I meant to do. Okay, excuse me. There we go. Hey, got it. Including Chaos, which is the one that I'm talking about today, and also with the To-Do group, which is a community of practice for OSPOs, open source program officers. Location-wise, I'm based near Bath in the UK. So I'll start with a very quick overview of the Chaos project, and then I'll tell you a little bit about some of the practitioner guides, which are a great place to start when you want to understand about Chaos and using metrics for understanding open source project health. So Chaos stands for Community Health Analytics for Open Source Software. It's focused on developing metrics and developing software to help people improve the health and sustainability of their open source projects. As you can see here, we are an open source Linux Foundation project. We are globally distributed with 2,000 plus, it's probably higher by now, members in Slack. So it's super busy, and there's loads of stuff going on that I don't get a sight of. I'm a bit peripheral, if I'm completely honest. And I will say it's a really, really friendly and welcoming and easy to get started with open source project. And it's one of the first ones that I've been actively contributing to, so I'm very happy to be there with them. What they don't do, or what we don't do, is medical health. I mean, community health sounds like medical, but it's not. And it's not for profit. And there's lots of ways that people contribute that's not code-based, because it's primarily about education, analytics, sharing best practice and things like that. There are some links in the slide deck. I'll make sure that the deck gets made available if you want to take a look at those links. And if there is any information that's on there that you would like to see in more detail. Also, the speaker notes. Just to say, this slide deck came from one of the other maintainers on the project called Dawn Foster, Dr. Dawn Foster, who some of you, I think, know. So she's provided me with the deck, and these are her notes that I'm cribbing slightly from, because she's much more experienced with the project than I am. I've only been here a few months, I should say. So contributions, if anyone is curious about coming to see the work we do and doing something with us. Obviously code, although I did say it wasn't just code. Metrics and metric model development, so what are interesting metrics to use when you're looking at open source project health. Community management, so the community is extremely friendly and sociable, and there's a huge amount of focus put on making sure that people have a really good experience coming as newbies, and that I look at this project as being a really gold standard for how to welcome new people into an open source project. And you can see, like, anything that you might want to do with any kind of work in the world, that's something that we need. So project management, design, website. I was working on the booth at Open Source Summit in Seattle, which was how I ended up meeting Greg Wallace, which is how I ended up working here. It wasn't that long ago, but here I am. I'm just going to skip through this a little quickly, because I know we may be tight on time. But what I'll mention is that the groups that we have in the project, we have an OSPO group, so for folks who are interested in understanding how open source is managed within organizations, governments, industry, that kind of thing. There's an OSPO group, there's an academic group, so folks who are interested in the research of understanding how open source projects are managed and made sustainable. There's a data science group. Then we've got geographical chapters. Chaos Africa is particularly vibrant, very, very busy. And then we've got some other programs where people can get more involved with proactive support like DEI, badging for events and projects. There are two pieces of software. One, they're essentially around collecting, analysing and presenting the metrics that you can gather about open source projects. Augur is the one that works mainly with GitHub, and Grimoire Lab can take data from multiple different sources. It's like a queryable dashboard and so on. Okay, I will not talk too much on this one because I think everyone's seen the XKCD with the thing at the bottom, and even on the Sovereign Tech Fund website, they've got a little picture of this, sort of version of this. But we all know that if open source projects, if you don't understand them, then you can't necessarily predict whether they are sustainable or pose a risk to your organization or indeed to your project if you're consuming another project. You can see here, I don't know how big this is for you, but we basically have, we basically look at metrics as being used primarily for two purposes. So historically, CHAOSS has been a bit more focused on contribution metrics. And so this is for projects that you're participating in. So most practitioners working in OSPOs would tend to think of those as outbound or upstream contributions. We have a starter project health metrics model with a collection of 4 simple metrics to help people get started measuring contribution. And these starter metrics can be used by researchers or practitioners. We've also been focusing on consumption metrics, which is the second type. These metrics are mostly related to inbound or downstream consumption of the open source software that you use in your products, services, and infrastructure or research groups. So when we think about metrics, even just on GitHub to see what it gives you, there are lots and lots of different metrics. And once you start to look around at data sources, you can end up feeling very overwhelmed by the metrics that you have associated with your project or with other projects, which is even worse because you don't always have the context of that project. So the way that we like to look at it is this goals, questions, metrics model. So you don't start with the metrics is the last thing because they serve your goals. So you start off by thinking, what am I trying to achieve here in relation to this project? What questions do I need to answer to be able to achieve those goals? And then what metrics might be able to help me better understand what's going on with this project? So metrics themselves require interpretation. The CHAOSS project spent quite a lot of time gathering up all the different types of metrics that could be used to understand open source projects better. Then they realized that people were struggling to interact with those and know which ones to pick, know how to put them together to answer questions and build a picture. So what Dawn it's mainly Dawn, but with a few other people helping, what she's done is she's created these practitioner guides. At the moment there are 4. So there's an introduction one which covers the overall concepts around metrics and how you use them. And then we've got 3 specifically on responsiveness, contributor sustainability, and organizational participation. And I know that one of the next ones that she's looking at is security. And if you want to see where they are, there's a link just here at the bottom. Just to note that in the guides, they contain lots of links as well to research. So let's talk about how we actually get started. With the metrics guides, or the practitioner guides, you essentially have to start off with an idea about strategy. So by thinking strategically about your overall goals, you're in a better place to determine whether a project is achieving the goals. Open source projects create a tsunami of data that can be overwhelming, but by focusing on your goals, you can develop a metric strategy that helps you focus on the metrics that matter to you most. So metrics, sometimes people have bad experience with metrics because they feel as though metrics are going to be used against them and are not necessarily used in context. So one of the main things that we say about metrics is that it's only really useful if you know the context in which they're being understood. So if you want to understand your open source project and its metrics, then you really need to make sure that you're collaborating with the community to understand what's actually happening under the hood. So one example would be if you're seeing fluctuations in some of your metrics, then it might be related to an event. For example, if a hackathon happened or a conference happened, you might see contributions going up or you might see contributions going down. If you know the cause for that, then you can understand the metrics in context. So let's talk about the responsiveness guide. So seeing large numbers of neglected issues and change requests on a project is a red flag because it can indicate that they either don't have enough contributors to handle the incoming contributions or they don't actually care or want contributions from others, which is something that you sometimes see in company-owned projects or in the scientific space where researchers sometimes open source projects that they only plan to use for their own needs. It's important for projects to respond to change requests in a timely manner because a quick response can help you to retain contributors who otherwise might become discouraged if they don't receive a timely response. Timely, thoughtful and kind responses to contributors indicate that you appreciate their work. Being responsive to the contributions of other people helps grow the community and improve contributor sustainability. While quick responses are important, it's also important to keep up with change requests and resolve them in a timely manner, even if the response is closing requests that will not be merged. It's easy to get behind on incoming contributions, and we all get behind sometimes, but not addressing these contributions promptly creates technical debt and reduces the chances that they will ever be merged, because older change requests are likely to have so many merge conflicts that they become too difficult to accept. In both of these responsiveness metrics, it's important to focus on the trends. If responsiveness is already improving, keep up the good work. However, if you see responsiveness declining, then it might be time to find ways to improve it, including recruiting more contributors and maintainers for your project. The Responsiveness Practitioner Guide has a bunch of details about ways to improve responsiveness for the projects you care about. So that was the first guide on responsiveness. The second guide, we talk about contributor sustainability. Now, there are some key metrics here. Contributor absence factor, which used to be known as the bus factor, but we tried to make it less visceral in the way it's described. Contributors and type of contributions, and you'll see how these are shown in the next couple of slides. So contributor sustainability is an important part of assessing whether an open source project and community has enough contributors for the project to be sustained over the long term. So contributor sustainability has a large impact on overall project sustainability. There are lots of projects with a single maintainer. Many projects struggle to find enough people to actively participate in their projects and continue to maintain them over the long term. The reality is that there are a lot of open source projects and not enough contributors, so maintainers are in desperate need for help across the various types of contributions needed to have a successful and sustainable open project. If there are not enough contributors to sustain a project, this increases the risk that the project will fail, which creates a variety of often significant challenges for the users, and other projects that depend on it. We recommend measuring contributor sustainability because there are a couple of things it can tell you. First of all, how big of an issue is your current contributor situation? If it's like this one, you should really focus on getting a few more people who can contribute and eventually be moved into leadership roles like maintainers. You might also find that there are people who are contributing more than you realized, which is the other reason that this is a good metric. This can help you think about who you can encourage to contribute more, or maybe find someone who could move into a leadership role. Reaching out to someone and acknowledging their work while encouraging them to do more can help quite a bit with growing your contributor base. Sometimes people just need a bit of encouragement, and you can ask them for specific things that you know they're good at. There are several communities that I've gotten more involved with because someone asked for my specific help. And Chaos is one of those. The catch here, and with many metrics, is that we don't want to just think about people who are making commits. This is a good start, but you should also be thinking about how you can move more people into leadership positions to be responsible for things that might not show up in your existing data, like documentation, community management, marketing, and other important roles. The practitioner guide links on this slide has even more suggestions about how to improve contributor sustainability for open source projects. How are we doing for time? You okay? All right. So organizational participation. So for this one, we're really talking about how are organizations engaging with an open source project. So we don't always spend enough time thinking about how organizational participation impacts the sustainability of open source projects. So you should also look for organizational diversity as part of the health and risk for open source projects. And I know that Ed was showing a graph that was a bit similar to this concept. If all or most of the contributions are from people at a single company, what happens when that company has a shift in strategy, or gets acquired, or runs out of money and goes out of business? Would the project be able to continue if the company pulled all of its employees out of the project? These single vendor open source projects might not seem risky, but they can quickly become unviable after a licensing change or when everyone stops working on the project. The biggest challenge with identifying trends for organizations in open source projects is that the organizational affiliation data is almost never accurate enough to use without doing some manual cleanup. This example is relatively clean compared to some others, but you can still see that about 20% of the contributors aren't matched to organizations. And I'm not sure how the FreeBSD data compares to this. I know we had a little white section on that pie chart. So I guess that's unsponsored work, but do we know who contributed it? If most of the work being done by people at a single organisation, the project might be riskier to use and harder to contribute to than a project with contributions that are spread out over many organisations. If you work for the dominant organisation, you might want to focus on getting contributors from some others by reaching out to people who you know are interested in the project. And again, there's more in the guide. So we don't have a guide yet on security, but I will say a little bit about it. It's a contributor to project sustainability. So really what we're talking about here is, are we seeing patches coming out regularly? Are we seeing vulnerabilities being fixed? And I don't know if you're familiar with this idea of a lib year. Anyone heard of a lib year? Okay, so it's basically the age of all your dependencies added together, if that makes sense. So here's a definition. In fact, I think, yeah, there's a link there, which when you get the slide deck, you can click on. If your system has a 1-year-old dependency and a 3-year-old dependency, then your whole system is 4 lib years old. And it's a way of comparing different open source projects to say, you know, is this one feeling like it's sort of healthy and looked after, or is it not so much? Okay. So here we're looking at the frequency of releases, even the tiny point releases. So it's critical that security updates and bug fixes land in a release in a timely manner, and it's important to get the new features out too. It's not necessarily that they're happening in a very quick cadence, but that it's regular. So the release frequency for a project is influenced by the size of the project and how many dependencies it has on other projects, and so on. You should think about whether a project is cutting releases frequently enough to help keep the project up to date and secure. So here are some extra thoughts that relate to sustainability for a project. So we tend to think of projects' sustainability in the corporate world as being something related to viability of a project. So we think, is the project likely to be viable over the longer term? So Gary White from Verizon developed 4 metrics models, each on one of the focus topics listed on this slide, along with a 5th starter viability model with smaller subset of metrics. The notes don't match the slide on this one. But we're talking about essentially what can we find out about the governance of a project, what do we know about the community of a project, and do we know anything about the strategy of a project, which can help us to make a decision about whether it's a project we should use. So just to finish up there, these are quite hard to read. We have a few links here which you'll be able to access when you get the slide deck. If you're interested in coming along to see how the CHAOS project works, it's very easy to get involved. You just come along to that link at the top and you have a look. If you want to listen to my voice some more, I host some of the podcasts and I produce most of them. And all the podcasts about guides are ones that I've hosted fairly recently. But there's a public community calendar if anyone wants to come and have a look. So final thoughts. The ease in adopting open source can lead people to use software without considering its long-term viability and sustainability. Not all open source projects are created equal, and some will be more viable than others over the long term. The success or failure of the open source projects you use can have a real business or research implications. When a project you rely on later becomes unviable, it can have negative implications for your users, customers, reputation, and research. One of the best ways to mitigate the risks associated with consuming open source is by contributing to the projects you use, so it can help to think of contribution and consumption together, especially for the projects that are most strategic to you. The CHAOS Practitioner Guide series is designed to help you think about how you can improve those open source projects that you care about the most from within as you contribute. Thank you. Time for questions or not? I'm also around if anyone has questions. So we need to get the next person on. Yeah. Okay. Are there any questions? Okay. Cool. Makes it easy. Thank you.
This adapter for here, USB-C, HDMI. That should actually make it much more. Let's see if that talks to devices.
With lights are online. USB.
That's USB-C, yeah.
USB. HDMI.
Should I switch on? that doesn't
no,
work. That doesn't fit.
USB, okay. And now,
Adapter, HDMI maybe?
uh,
Or do you need to set something up
I have a new laptop. My FreeBSD
best
laptop
test
is off.
to do
Yeah.
that at a conference. But that's okay. I think
Anyway,
we have-
slides are online.
Okay, then someone
yeah,
else
it's
can-
all on Google slides.
Yeah. Because mine is still charging.
Maybe
But it should have it.
just a second.
There is an adapter, but it's not showing. Maybe if I
No. We need an HDMI.
So it does recognize it, but it doesn't seem like. What, do you have some kind of
Yeah, on
monitor setup? That
yeah,
shows
they
you
are
what
on
it does?
FreeBSD Dev Summit.
That's some kind of vision accessibility right there.
Oh, it's a new laptop with Windows for. I am taking Excel, PowerPoint.
But apparently, the resolution is too big for the projector to send. Maybe that's it.
They are online.
Yeah. Okay. Oh yeah, I saw that.
Yeah. Some guys.
Okay, maybe we'll try
I
my
don't know
laptop.
how to set up. Yeah. Okay, thank you.
That should at least give us
Super polite.
Yeah, I mean, if it's on the wiki, then makes it easy. And I think we can do full screen even. Enter full screen. Let's see if mine works or if they mixed up something. So Windows laptop didn't work, but mine did. So think of that, and let's continue. So this one is for
Okay. Oh, okay.
plug it in. Here somewhere. Set it down and push it up.
Okay.
Try this out.
Okay.
It should last.
Thank you. It's a full screen. The German full screen. Okay. Thank you. Can you listen me? It's okay? Okay? Okay. I'll talk about vision accessibility. I'll send an accessible version of this slide to the accessibility mailing list. This is the overview. At the end, I'll give you my contacts because I prefer to receive right questions because my hearing is not perfect. So maybe I could not understand your question. I'm Alfonso. I come from Italy. I am a SUSE committer. Anyway, I usually create projects from scratch in my repository, from the kernel to the user interface. This isn't a super technical talk. I describe the problems and the roadmap with new features and possible solutions. Vision impairment uses ask emailing list, forum, social networks, how to use FreeBSD. In particular, Linux uses ask where the documentation for accessibility is, and after they can continue to use open source assistive technologies. But we haven't got documentation for vision accessibility, and open source tools are built mainly for Linux. I describe a roadmap to provide a starting point for vision accessibility to allow vision impairment users to use FreeBSD. The task is new projects in source, ports, and documentation, and adapting the projects for Linux. Thank you so much to the FreeBSD Foundation for sponsoring this work. This is not a medical talk. Disability, including vision disability, is a spectrum. Can be permanent, temporary, situational, and And vision impairment are different types and different levels, mild or severe. So we will see some screenshot to understand the problems that colorblind, low vision, and blind users tackle using a computer and of course FreeBSD. We will see a lot of images. Color blindness. Color blindness. This is an example of color blindness. The image at the top shows an image in full color perception. The first image at the left bottom shows a red-green color blindness. Center bottom, blue-yellow color blindness. And the last image, no color perception. This is another example of color blindness with some medical word. Anyway, what's the problem? I use our websites to describe the problems, but I don't know if our websites are accessible or not accessible. I am not a web expert. Anyway, this is our git.freebsd.org in normal vision. As you know, we use colors to represent different information. For example, a text in green is a new file, a text in red is a deleted file, and the text in blue is a changed file. But not everybody can see red and green color. As you can see at left image, at right image, somebody can see new and deleted file in yellow and green. Okay, the left right image, new and deleted file in yellow. This is another example of color blindness. Not everybody can see blue color. As we can see at right, somebody can see new and change the file in green. So, we cannot rely on colors to represent information. We have to provide an installer, also in IT contracts, to document how to set user interface in IT contracts, and also to provide in a simple way to set text user interface, text user utility, text user interface utility in IT contracts. These features are useful also for low vision user. We will see more example later. Low vision and blindness. World Health Organization estimates 246 million low vision people and 39 million blind people. This is our main site in normal vision. We will see some simulation about low vision. This is an example of patched vision. An example of loss of central vision, in the center. Okay. Loss of visual field. Loss of visual acuity. And another example of visual acuity with the VT4. At left, normal vision. At right, loss of visual acuity. Depending on the low vision type and the level, some user could set font size, set mouse color, shape size, magnify a screen area, set screen resolution, of course, and so on. Of course, you have to document these features. And after low vision simulation blindness. Of course, blind users cannot see the screen. How can they to use a computer? A screen reader. A screen reader is an aesthetic technology that reads elements on the screen and sends out to a speech synthesizer and do a Braille display. It works with the operating system and the desktop environment. Screen readers can be useful for low vision people and are needed for blind people. A speech synthesizer, also text-to-speech, is a technology that turns written text in synthetic speech. We have Hoka in port, it just runs. It provides a speech synthesizer and a Braille interface. We will see a demonstration later. But we have two problems. Hoka is suitable only for graphical desktop environments. So vision impairment users need a sighted person to install and to set up the OS and the desktop environment. The second problem is VT4 and the speech synthesizer cannot communicate. So as you can see, VT4 is not accessible without seeing, also for a low vision user. Image to the right. And now a reference display, a Braille display. A Braille display is an electronic device with mechanical components for reading and writing Braille characters. We use keys to write Braille characters, up image, and the dots to read the Braille characters, but on down image. A Braille character is represented by cell matrix. A cell has 6 dots, 3 rows and 2 columns. Nowadays, a cell can have 8 dots, 4 rows and 2 columns, image at the right. New dots are for computers. For example, the extra dots can indicate where the cursor is in a text editor. This is an example of Braille alphabet with the 6 dots. Actually, this is on only one possible Braille alphabet. We will see more later. Just 2 words for Louis Braille, from the Louis Braille museum website. Louis Braille became blind at 3 years old. He attended the Institute for Blind in Paris. In the school, Louis Braille and the students can read the books. With the books with the letters in relief, as you can see there. Anyway, students cannot write. Please image to close your eyes and to write without seeing the paper. It is not possible. At 12 years old, Braille tested a new system by Charles Barbier de la Serre. He created the dots so students can read and can write. Anyway, this system had some problems. For example, it is only for French phonetic alphabet, no numbers, no dots, no colon, only phonetic alphabet, and so on. Louis Braille improved this system. He reduced the dots for character, so any character can fit under an index finger. He created a complete alphabet with the numbers, colon, comma, and so on, a complete alphabet. At the image at the left, we can see A and Z in relief characters in a Barbier system, and the last, Braille characters. And at the right, the first Louis Braille original French alphabet. Actually, a lot of alphabets tactile system for reading and writing were created in the past, but nowadays Braille is the most used. Nowadays, users can write characters to a computer by using a keyboard, so some Braille display has not got the keys, only dots. No, so a user can use the normal computer keyboard. The Braille display only reads from dots. Braille is not only for French alphabet or Latin-like alphabet. This is an example of music Braille. Maths. Korean Braille. Japanese Braille. Mainland Chinese Braille. And the Taiwanese Braille. And Unicode. Unicode defines 200 fixed patterns for Braille, the 8-dot cells. It doesn't define a special meaning for each pattern. We use translation tables to translate from blank characters from to Braille. We will see an example later. A skill reader, both speech synthesizer and Braille display, is suitable at handling text, so it is excellent with a command line interface. FreeBSD could be an attractive operating system system for vision impaired users because it provides a powerful CLI to set up and use the system. But VT4 and a speech synthesizer cannot communicate, and we haven't got a Braille display subsystem. This is the roadmap. This roadmap is just a starting point for vision assistive technologies. The rationale is simple, feature request from users. The step one is documentation. Why? We have a lot of ports for accessibility, several are for visual disabilities. Just some example, the OCA screen reader, port option CLI, we will see an example later, the eSpeak and G-Speak synthesizer, and we have Eddy browser. Eddy browser is a browser, an editor, a chat, and a mail client developed by blind programmers. At the left, we can see our website in a graphical browser. At the right, we can see our website in Eddy browser. No color, no icons, no buttons, no images, no only text. We have LibLouis. This is an open source Braille translator and back translator. It provides libraries, utilities, and several translation tables. This is an example of our description in our site. This table is English have several tables. This English US grade 2 is a table with transaction. We could use this utility in next conferences for print accessible brochures. And desktop environments allow to set up graphical elements, font size, mouse, screen resolution, themes, and so on. Some desktop environments provide an accessibility menu. Of course, we should document these features. So the step one is a new accessibility handbook with the vision chapter. It should document the tool we already have, some possible section or paragraph. Of course, paragraph for height contracts, for desktop environments, graphical terminal and VT4, a chapter for low vision, font size, manifest screen area, screen resolution, for desktop environment and VT4, and of course, a chapter for blindness, how to install and to use OCA, and the port option CLI. Step 2 is the height contrast. Height contrast can be important for photosensitive, colorblind, and low vision users, depending on disabilities. The step 2 is providing text interface utilities in height contrast. The first task is the BSD install. We have a bad feedback from an user from a social network. How to choose the right colors for height contracts? We have a discussion in accessibility. Height contracts as a metrics. A volunteer tested and wrote a report available online. The winner is black and white, so we don't rely on colors to represent information. Another task is how to provide a simple way to set up height contrast for BSD install and two utilities in base. BS Dialog has dynamic theming. Both library and utility allow to set up themes at runtimes. In particular, the utility provides two environment variables, no color, and another variables to select a theme file. So these two variables, no color and BS Dialog theme file and contrast file in base, can be a solution, a simple solution also for utilities base, suitable both for VT4 and graphical terminals. Step 3 is VT4 read by speech synthesizer. Hans-Peter Silaski created the VT-Speak to read the VT4 by speech synthesizer. It just runs. We have reviews. The idea is a daemon uses CTL to get buffers from VT4. Then it passes the text to a speech synthesizer. We tested it with speech and tested also the browser. We have a discussion in fabricated. later. Kernel side can be improved. Some possible solution, a new devs driver or adding a new OCTL to BT4. Of course, I use it like a proof of concept and a starting point, and I will open a review to find the best solution. Step 4, a Braille display subsystem. BLTTTY, I don't know the pronunciation, is the open source solution for Braille displays. Mainly it is a daemon. It reads the Linux console and passes the text to a speech synthesizer. I only took a look at it. It has interesting features. It partly works on X11. Uses a need OCA to know graphical elements because BLTTY does not read window title, window typal, buttons, and so on. It is built on Linux under GPL. I consider to write it from scratch. I think this is the ideal solution. But it has got several drivers. Just for example, in blue, the drivers, and in black, the Braille displays. So for this standpoint, I try to adapt the BLTTY for FreeBSD, mainly to use its drivers. Of course, we can consider other solution in the future. I haven't got a Braille display. They are very expensive, mainly depending on the number of cells. I found a cheap device for $190, but they don't deliver to Italy. So for testing, I'll use the BLTTY virtual device. I do a call for testing, and I could ask to a device from a blind and low vision people association. The step 5 is a new accessible CLI suitable for the screen reader. The problem is mainly related to the OS installer. OS installer has a text user interface. Text user interface is a well-known accessibility problem. We have a discussion in accessibility. Screen readers cannot read the text user UDT. What's the problem? In this terminal, we can see a blue background, a dialogue. Its type is a yes, no, a border, a title of the dialogue, a text inside the dialogue, hello world, 2 buttons, focus on the yes button, a black shadow. The problem is the screen reader sees and reads what this text interface is really, a terminal full of text. The real problem is semantic. The screen reader just read text without understanding the background, type dialogue, borders, title, text inside, 2 buttons, and where is the focus. These components are just text in a terminal, not like widgets in a graphical libraries. So, how to provide an accessible installer? What's the ideal solution? We have a discussion in accessibility for the text user interface problem. Screen readers handle text, so a sample command line interface is the best solution. Is an example for our installer. I found a paper from Google. It's a study. It confirms command line interface is suitable for a screen reader. Just we have to avoid a chart, the first image, progress bar, the second image, and the tables. For example, top utility. So top utility. So for an accessible installer, the task is translating a text user interface dialog to a CLI dialog. Probably I'll write a new utility, a dialog, accessible dialog, as a dialog, screen reader dialog. There isn't official documentation on this topic, so I'll use port option CLI like a proof of concept and starting point. It's a good solution for ports. Let's see. Ports collection is a key feature for us. Usually we run make config imports, then we see a text user interface dialog. For example, in this case, its elements are a title, VMI, 3 list, 1 radio list and a checklist. A list can have a name, select and unselected items, focus on item and on button. Some big port can have items up and down on the screen. Some ports can have an extra button for F5. Of course, this is not accessible. A blind user can't set up ports. We have a discussion in accessibility. I wrote port option CLI after a discussion to provide an accessible solution for ports. It has positive feedback. A blind developer tested port option CLI with the Linux and an iPhone with a screen reader and the CCH to a FreeBSD server. It is in ports. The idea is, of course, a user run make config imports. Then port option CLI prints port name, number of list, and options. A basic CLI allows to navigate a list and select an item. Other commands are in a manual. Let's see a demonstration with port option CLI, XFCE terminal and Docker. Just a minute, it's on YouTube. Audio is off. Can you listen? Okay.
Audio or full audio or what?
Okay.
Yeah, that's full. I'm not sure if they have audio while I was.
Make config. Configuration for the open-0.9.1 port. One list total 2 options. Reverse mode on N colon. Next. D colon. Previous. R colon. Reprint. Space colon. Select or unselect. List 1. Generic options. Checklist with 2 options. 1 NLS colon. Native language support. Disabled. 2 business colon. Enable support for plugins written in Python. Disabled. Option pin with enabled. End configuration Q colon. Save and quit. A colon. Abandon without saving. T colon. Go to top. Save and quit. /us/port/editor/neobin/number.
Okay.
Make config.
This is the text of the previous example. I added the keys. Enter, V for verbose mode, and for next items, Q for quit and save, a simple command line interface. So, step 6 is unless install a suitable for an screen reader, adding a button to install in plain text, as you can see in the example. Mainly using the new accessible utilities. This is an example. The child just as a Practitioner at the left. Anyway, OpenBSD has a CLI Practitioner, so it is a proof of concept. And to the right is progress bars. Anyway, the Google's paper gives some tips for inaccessible bars. This will be a proof of concept because BILTTY and speech synthesizer are under ZPL. And I don't know if I can add to BSD install a totally different front end from dialog and Xdialog. Anyway, I won't waste this work. I am designing an installer. It is a personal project, not in vision accessibility. Anyway, it will be open source, imports, can exist with FreeBSD install, and it will be multi-front end. Of course, a front end for accessibility, a front end only in plain text. It will be multi-language, multi-mode. I wrote an email to hackers some months ago. Step 7, again documentation. Of course, I documented new features. You potete the accessibility handbook from the user feedback. Probably I will write a new document in plain text, a manual or a text file, suitable for an skill reader, of course. It could be a starting point with basic information and the links to what resources for blind and low vision users. Sorry. This is the roadmap recap. 1, an accessibility handbook. 2, text user interface in high contrast. 3, beautiful and speech synthesizer. 4, a Braille device of the system. 5, a new CLI dialog utility. 6, proof of concept of an installer for a screen reader. 7, again documentation. The rationale is a feature request. This roadmap is just a starting point. Accessibility is not an endpoint, it is a work in progress. Just some idea for the future. Of course, I implement this roadmap. Then I present this work to accessibility conference. Some blind users, system admin, developer complain no attention from open source community. Have an idea, wiki page for Braille displays, a screen reader in base, and of course getting and providing a feature request from users. I have indeed, my contact, my mail, accessibility for public discussion. I'll be in Dublin until Monday. Thank you. I am half diff.
Are you looking for any particular help or support?
In particular?
Are you looking for any particular help or support with this work?
For testing Braille devices, some feedback from color blindness. I think to complete in 6 months.
And do you need more accessibility developers or designers?
Are you?
Do you need any more accessibility designers or developers?
I think to complete by myself. Any help comunque is best.
Let me ask next. So what interests me is what's your general motivation in this, or what kind of, how you got into these kind of topics, which is very interesting and enlightening, like what kind of impairments people have to, live with. So what's your background in all these topics?
Because I work on this, I started to contribute to FreeBSD 5 years ago. I maintain ED browser. A guy from an Australian blind uses wrote me an email, so it motivated me. 2 years ago, I had a sudden disability to my hearing, so I understand disability problems. So I want to help vision people. We have an accessibility mailing list. A lot of people would like to use FreeBSD, but they want a Braille system, a speech synthesizer, and so on. My first conference, I'm shy.
I have 2 questions. The first one is regarding terminal support, so converting the TC, so 2-dimensional interface to the 1-dimensional one, basically.
Exactly.
Yeah. So we, so Unix world had some installers that supports the dumb terminal, for example. So we used to have good support for the 1-dimensional terminal output for the installers, and gradually we shifted from such a boring output to the more rich so for the normal people. So we can probably look back to the old implementation that supports the one-dimensional one. And so that is just a comment. Another one is about the documentation. You mentioned we should have plain text version or some plain version of the document, not only feature-rich graphical representation in the documentation we currently have. But I am interested in your comment about the hyperlink whether hyperlink is working for the visual the people with visual impairing or disabilities. So we can keep the hyperlink things even in the plain text, or we have to get rid of all of the such a jumping from the document to another.
To create a plain text. In the next, we should test also images, online image for accessibility.
Mm-hmm.
It is another task.
Okay.
I am not a web expert anyway.
Okay, thank you.
This is the talk.
Too fast. I can listen.
lunch is at 2.
Yeah. No.
Lunch is at 2. No, oh, could you have another talk? So TLB shutdown to Azure optimizing those or something like that you had. But we're able to have a little bit of break. You weren't here at the start. Lunch is at 2 every day. So we could do a 20-minute break. Yeah. If you guys would appreciate it. Just use this.
Where's the other one? Up there?
I'll find it.
Okay, we're trying to resync with the schedule. That's actually quite good. But let's first have a little bit of a break, 20 minutes, and so we can start again at 1. And again, lunch is at 2, so we have a bit of time for the talk afterwards, the TLB enhancements in Azure. So let's have 20-minute break. I think coffee and other liquids are over there. And then at 1, we start again in here. All right? Cool.
So, shall I start? Okay. Hi everyone. Very good afternoon. So, I am Shouradeep, and I am working in Microsoft Azure and FreeBSD for last 3 years. And Wei, who is not present today, he is one of the FreeBSD committers, also working in Microsoft Azure for last few years. So this is a recent work which we have done in FreeBSD kernel to improve the performance of TLB shootdown in Azure. So just a brief history of FreeBSD in Azure. So FreeBSD has come in Azure as public offering in 2016, and that was a collaboration between the FreeBSD Foundation, community, and Microsoft. And from there on, FreeBSD is regularly coming with the all latest releases, stable releases in Azure. Right now, FreeBSD is available for both Gen 1 and Gen 2 VM in Azure, as well as for the ARM and AMD, both the platform. AMD64 means Intel and AMD64. So now let's come to the actual thing, that is TLB. So translation lookup buffer, or TLB, is one of the most important performance related thing which is there in every CPU for enhancing the performance during the page lookups. So whenever there is a new page requirement, so it is looked into, it is not present in the cache, so it is looked into the TLB, and from there TLB, if we get the page, it is used. So it is a par code cache, you can say. Every core has their own TLB in the physical system. Now, in case of Azure runs on it uses Hyper-V as its virtualization system. So we have similar virtual TLBs in the hypervisor for every virtual CPU which has been offered to a particular partition. So what we mean by TLB flush and TLB shootdown. So TLB flush is whenever any process, any context switch happens in a process, or a process is doing any memory invalidation like unmapping, or it is doing some permission change, etc. That time we go with a TLB flush. So, and it invalidates, either it can invalidate the whole TLB, or it can invalidate a part of it, or it can invalidate a particular page itself in the TLB. And in a hyperscaler system like which is in Azure, so you need to synchronize this TLB invalidation in multiple CPUs based on what all CPUs this particular address space is active. So when you are doing the TLB invalidation, the AMD64 architecture provides this instruction, invalidate page, that is INV LPG. And it has already got, when we are doing it, so it is a performance critical thing. And when we do for multi CPUs with synchronizing the TLB in multiple CPUs, that time we need to do IPIs to all those CPUs where all this TLB is active, and that IPI is a thing which needs to be implemented by the operating system kernel to initiate the IPI for all those particular codes. Now, why this work is critical for us or important for us is that this IPI is when we are doing just from the kernel, we are doing the IPI. It is quite, it has got a performance toll, because the processors which are virtual processors are mapped with the physical processor, which is not known to the kernel by default. That has been maintained by the hypervisor. And whenever we are scheduling the IPI, this is a blocking call. So it hits bar code and it waits for that invalidation to get finished, and then it comes back. And that particular processor code gets in a waiting state till the invalidation is done, and then it resumes its next instruction pointer. Now, this mapping of this CPUs and the sending the IPI on this virtualized processor is a performance impacting factor. So the solution we thought of in this is using hypercalls. So what is a hypercall? Hypercall, as we know it, is an interface which is provided by the hypervisor to the guest OS to use that hypercall as an interface to communicate directly with the Hyper-V and send particular commands. In this case, Hyper-V provides hypercalls for this TLB flushing. So it provides TLB flushing for multiple, like more than 64 CPUs as well as less than 64 CPUs. There are two different hypercalls they provide, as well as it provides certain flags by which you can invalidate a particular page, you can do set of pages, or you can do non-global pages as well as global pages. So the implementation required two things. First is Hyper-V's guest enlightenment, that we need to make the guest aware that these features are available in the Hyper-V and use them. Second is to set up the functionality to use those hypercalls and do the flushing. So for this work, we have done following major changes. So in existing FreeBSD, not existing, prior to this work in FreeBSD for the remote TLB shutdown, we had SMP targeted TLB shutdown, which is a native TLB shutdown, and it uses the IPI. So we had refactored that code, and whenever the system realizes that it is running on Hyper-V, instead of going with SMP targeted TLB shutdown, it will bypass to the Hyper-V VM TLB flush. And this initialization happens after the Hyper-V is initialized in the guest OS in the FreeBSD. And then we have introduced new hypercall mechanisms for processors where the queue size having capacity of the processor more than 64. That needs a repetitive hypercall. Then we have added this new hypercall systems, and also the implementation has used the FreeBSD invalidate opcodes to decide what type of flushing needs to be done. The implementation has been done mainly in 2 commits, and other than this, some few more commits have gone into this work. One which has enabled a sysctl switch for the FreeBSD. So that switch by default is enabled, so it will be using the Hyper-V TLB flush when running on Azure. But if required, you can disable that switch and it will go back to using the native SMP TLB shutdown. Now here are some interesting factors. So as we can see, we have, so one important thing, this performance number gets impacted as the number of core sizes increases because of the IPI. So if we see, we have taken a 48 CPU based system in Azure, and then we have measured the performance matrix. So the IPI based TLB shutdown was taking 27 microseconds, whereas new hypercall based system is taking 14.7 microseconds on average. To do this, we have actually used FreeBSD build. Means we have built FreeBSD with J100 to hit as many as TLB shootdown. And there we have used nanogate uptime and command API to get the particular SMP TLB shootdown performance. Now this is a comparison between the Intel and AMD in Azure. So the AMD particular one, if you see, that has got IPI much bigger number than Intel because of the one is CPU frequency. So if you see, the CPU frequency in Intel is higher in this case. But both the cases we can see near about 40% improvement again. Now, this is the comparison we have done between Azure SKU, which has got 16 CPUs and one with again 48. So as I was telling, so when the number of cores are increasing, we can see the IPI-based TLB shootdown is also increasing. So it is 27 microsecond, whereas this is 12 microsecond in case of 16 CPUs. And Hypercall has reduced again, we can see, like 40%. Now this is another interesting. So we have compared quite a similar SKU from AWS, and at least from the CPUs, number of CPUs, it matches. Yeah, RAM size we have not found, which matches the one which we have got in the Azure for this. So, but if we see that IPI in Azure and AWS, it was taking approximately similar time, but after the introduction of Hypercall-based mechanism, Hyper-V interfaces, we have reduced it in 14.7. So it is also having a better performance number with respect to AWS currently. So this was done with FreeBSD 15 build. So these are the two challenges which we have faced during this course of work. One was currently, when we are doing this benchmarking, we are seeing these performance numbers on the micro level when we are measuring the total TLB shootdown in a big workload. But in the macro level, for the whole work, we are not able to find much differences. So it will be good if anyone can suggest from the audience or from the foundation or community to give some idea on what kind of macro workload we can test to get a good number. We have already tried with multi-thread mmap and munmap programs by pinning affinity to different CPU cores for the threads. But still we are not getting substantial number there. But yeah, micro level it is always given. And another thing is that when we started this work, so we found that Zen had done similar kind of work, but Zen hypervisor. But what they had done, they have actually used the IPI to change to use the Zen IPI mechanism instead of using the normal kernel IPI mechanism. But then they were using the invalidate LPG call only to do the part CPU core invalidation. So they have not offloaded the TLB shootdown fully to the hypervisor, maybe because the hypercall is not present for that. So one thing we have found, there is no generic paravirtualization framework which is present in the BSD kernel right now, with which we can offload certain works like IPI, spinlock, or this kind of MMU related operations from operating system or from the bare metal based operating system to offload it directly to the hypervisors. So yeah, we are thinking of doing it. Maybe we will need the help from the FreeBSD community if we want to introduce this paravirtualization framework in FreeBSD kernel. And these are the references of the work. So this is the part CPU, so Hyper-V uses CPU schedulers, which is actually critical for this kind of IPI work. So the kind type of schedulers has been mentioned here, what Hyper-V uses. Second is the TLFS, which specifies all the different Hypercall commands and their details. Third is, this is a paper published on IEEE, which discusses the similar problem which has been seen in virtual machines running on hypervisors, different type like KVM or any other hypervisors, where the hypervisor-based offloading is missing. Yeah. Thanks. So any questions? I guess I've finished quite quickly. So no questions? Okay, fine.
So Kelvia asks, do you have any stat gathering for TLB shootdowns?
Sorry, can you repeat the question, please?
Do you have any stat gathering for TLB shootdowns? I don't know.
Do we know how many TLB shutdowns we have?
Yes, yeah, we have that quantification. So
I don't see it in systat or syscontrol or anything.
no, in that way you cannot see because that currently systat, yeah, doesn't provide. But what we had done, we have actually added this micro get time and nano get time function. Just so if you hook to SMP TLB shutdown function, which is the parent function, if you hook that using, I guess you can par for also something, you can hook that. So then you can get how many times that is getting called. So we have found during our work, like when we are compiling FreeBSD full with the world and kernel we are building in a fresh system with 100 threads and 48 CPUs, we are getting around 50,000 times the TLB shutdown has been called. Yeah. Any more questions? Okay then.
Do you have any tests to verify that your shootdowns are actually happening? I ask this because we had a bug 4 or 5 years back where on Zen shootdowns weren't happening properly, and it took a surprisingly long amount of time before we found the bug, because most things still work when shootdowns don't happen.
Yes. Yeah, so we have tried with different TLB thrashing or TLB shutdown initiating programs, like I was mentioning, but they will initiate the shutdown, but then to see the performance number, it is actually, we have to put a micro get time before and after the calling of the function, just to get the total number of microseconds and nanoseconds have been used. But when we are doing it on the macro level, total time consumed during the work, it is not substantial, because maybe one thing is that current, whatever we have tested, the number of CPUs is like 64 kind of that. So it impacts more as you are growing the number of CPUs more. So that time, that value. And also, we got that information that SAP has something that if we done, but we don't know how, actually, frankly speaking, I don't know how to configure SAP on FreeBSD. So if you are running SAP, it actually does it uses a lot of TLB shootdown, and it gives a macro level value. So, but when I was discussing with Wei, so we were like, okay, we don't know how to do that SAP in the FreeBSD. Maybe, yeah, we can figure that out. And any application, if someone can come up with any application, because this is right now in the upstream, and FreeBSD 15 has got this stage, so anyone can write it and try it on the Azure, any application, which can showcase this thing. Anything?
AP virtualization in general?
Okay then, I guess, good. Okay, thank you everyone. Yeah.
Okay. Yeah, so this is the time to be having an empty server, kind of nicely compensated this way. Either you work a little bit quiet, or you talk among yourself, or there's a session for impromptu stuff that you can present or come up with or discuss even with the audience until lunch is arriving. But I don't see any volunteers or hands going up. Okay, so that's fine. So I will be gone after lunch, doing my tutorial, and John will take over depending on what kind of things we want to talk about. But if nothing comes up, then of course everyone can hack on the latest stuff or close PRs, reviews and stuff. I guess you won't be bored. All right, thanks.
Davis, myself, John Logan, Mark Johnston, and Jessica Clark will all work together on a research project for a CPU security architecture extension, is that a good way to say it, called CHERI. And I'm going to hand it over to Brooks to get us started.
All right, thanks, John. The first thing I'm going to do is say I was remiss and I did not put Ruslan on the slides. Ruslan is responsible for all the pixels you see on this screen, making it from the HDMI port and up to here. So, yeah, I'm here today to talk to you about CHERI BSD. My slightly snarky title is memory safety in FreeBSD without rewriting. In lieu of the Rust talk, which all the Rust email threads and whatnot. We provide memory safety for C and C++. So I'm going to move on here and talk about what CHERI is. Many of you have probably seen, in fact, this slide in some, or at least these words in some form in the past, but a refresher for everyone who hasn't. So CHERI is a processor architecture protection model. It composes a capability system model with hardware and software. And it does this in part by adding new security primitives to instruction set architectures, so ISAs. And then it's implemented in the microarchitecture and in the memory controller on the CPU and on the system on chip. And it enables new security behaviors in software. It is specifically designed to mitigate vulnerabilities in C and C++ trusted computing bases. So think hypervisors, operating systems, language runtimes, browsers, whatnot. It's important to know that these runtimes are part of even systems like Go, which try not to actually use C at all. When they talk to another through a foreign function interface or something, they're using a C interface. So CHERI can help in those cases. CHERI provides fine-grained memory protection and deterministically closes all manner of attacks. It can prevent arbitrary code execution in many cases, and it makes it really hard to exploit. In fact, one of the problems we have in demonstrating the compartmentalization that one of us at least will talk about a little bit about later, is that we don't have any good attacks against CHERI programs. So it's really hard to say, oh, well, now you can't break out, because now you still can't do anything most of the time. We know there will be attacks, but for now, it's actually quite hard. In addition, and I guess on top of memory safety, CHERI enables extremely fine-grained compartmentalization. So we'll get to that later. So how does it work? Well, the fundamental piece of CHERI is the CHERI capability. We take an existing pointer, so a 64-bit virtual address, and we extend it to 128 bits plus a tag. And inside that extra extension, we add bounds and permissions and some other things. And then we require that the capability be manipulated with guarded manipulation, which is to say special instructions are used to make any changes. If you use those instructions in a way which would violate the properties of monotonicity, which is to say, try to make the capability reference something it didn't already, then the tag is stripped and you can no longer use it. In a CHERI system, all memory accesses are via capability. So that's either explicitly, which will be the case in most of the things we're talking about today, where you have a load via capability instruction, or implicitly. So in a hybrid programming model where most pointers remain integers, there's a default data capability and a default program counter capability. And that provides us with complete backward compatibility. So to make it all work and to provide memory safety, we do have to restrict C and C++ a little bit. Most of the changes are quite minor. They're around clarity about pointer provenance expressions. For instance, if you add two UN pointer T's together, the compiler may not be able to figure out which one of those is actually a pointer and which is an offset. So you'll need to tell it. And then type use must preserve pointer provenance, which is to say you can't take a pointer, cast it to a long, and then cast it back to a pointer, because a long doesn't have anywhere to store all that metadata. So, and then likewise, copying, so using memcopy to copy a data structure, or a sort, sort doing a swap, you need to modify it slightly. For ordinary programs, these considerations have little impact. For instance, OpenSSH required maybe 3 changes and currently requires 0. And many programs in the FreeBSD tree we've never touched. So it's pretty cool there that we have pretty strong compatibility. And generally speaking, the changes we have to make improve the clarity of the code. It's you're simply expressing your intent to the compiler in a better way, and then hopefully you're also expressing it better to the next person who has to read it, including yourself. And then there are a few bits of CHERI, such as changing the bounds on a capability, or changing the permissions, which are outside the C language. They can't be expressed in standard C, and for that we use compiler intrinsics to use the appropriate instructions. So once you've made these changes, what you get is a memory safe C and C++ for some definition. In particular, it's spatial safety at the level of C objects. So a thing returned by malloc, or something a variable that you create, a global variable, global array, global integer, whatever. The spatial safety is at that level. So if you have an array, by default, if you pass a reference to some element of the array, you're still passing around the bounds of the whole array, because otherwise not doing so would violate the expectations of C programmers in the C standard. In addition to the spatial safety, we've been able to build a Heap temporal safety, which Mark will talk about in a bit, where we prevent use after reallocation. So you don't have to worry about two malloc returns aliasing each other and bugs happening there. I guess to continue on sort of what has to change, you might have noticed that in the example of the capability that we had a 64-bit address, and then we only had 64 bits of metadata, but somehow we have to have a bottom and a top of that, a base and a top of the valid range. So to make that work, we're compressing the we're compressing the bounds relative to the address. That in turn, that's so basically like floating point, and that means that larger regions have less precision. So if you allocate anything with, or if you want to set bounds within a page, you always get byte precision. Once you get to larger sizes, at some point that decays and you have to add a little more padding. Now, the good news is that's pretty natural. Your allocators already do that because nobody needs an allocator for, a megabyte -1 allocations. That's just not a thing. And it would be pretty ridiculous to cater to that. So typically these changes are pretty small, but there are some oddities. So if you have a really large, weird-sized allocation, you may need to pad it a bit. Or things like the pattern in the kernel, where we allocate a UIO and then also the space for the IO vec that goes with it. We may need to either add some padding there or split them up. Generally speaking, though, pretty minor changes. I'm not going to go into any more detail about that here, in part because I have a talk here, so you should skip Kirk's talk and come to mine if you're interested. Also, I think Jason's, sorry. But yeah, so now I'm going to try to give a quick demo here. We'll see how it goes with a hand mic and keyboard. So the first thing to note is I am running on a CHERI system. So it shows itself as FreeBSD because changing the name and uname would screw everything up, so we don't do that. But it is running CHERI BSD. Probably the interesting point here to most people is that, let's see, where are we? So yeah, so the kernel is a ARM64, ARch64C kernel. AH64C is what we're calling the Morello extension. So this is running on ARM's prototype hardware. It's a 4-core, 2.4 gigahertz ARM v8.2 system with CHERI extensions. And then the other thing of note here is that we have generic Morello peer cap. The peer cap part means that in this kernel, all pointers are capabilities. There's another compilation mode that we won't talk about in really great detail today, where only some pointers are capabilities, so specially annotated pointers. This is really useful for bring up sometimes, but it makes for very large code diffs, and it's kind of annoying in a lot of ways. So we're mostly not using that. But here, so we're running CHERI. Now let me pull up the next thing. So here we have a simple program. We don't have quite enough listing, sorry. But a simple program which overflows a buffer. There's my GDB foo is not up to this particular task. But anyway, here we go. So yeah, so we have a buffer, character buffer, or a character. We have a buffer, pointer to the buffer, and we're going to try to write too much to it. So here we go, and then let's go ahead and run. Or no, continue, that'll work. There we are. So capability bounds violation. We received sigprot. The interesting thing here is that we have a capability here. We have a, let's see, we need to show B, print B. We have a buffer, it has a fixed length. And actually, let's go backtrace. I think that's what we're, no. It's been optimized out. Usually, we would see the memcopy failed, but here we are. Anyway, we got a bounds violation trying to execute the buffer overflow. So that is there. And then let's go look at the pointer type confusion. Yeah, so here's another example of CHERI and the monotonicity constraints in particular. So in this example, we have a union of a pointer and an integer. We assign a pointer to the pointer value in it, and then we increment the integer. Now, because of the way they're laid out, the integer is the same as the address. So we would attempt to increment that pointer using an integer instruction rather than a CHERI instruction. So now let's see how we do. Why is that not? Why is it being uncooperative? There we go. Run. That would help. Now we have a CHERI protection fault, and if we take a look at the pointer, so print we'll notice that it says it's invalid, and that is because the integer operation on the capability resulted in the tag being cleared. So you can't use this capability anymore, so when we tried to dereference it, it didn't work. And this is one of the reasons, in fact, why I was alluding that it's often hard to find demonstrations. Well, so we can defeat buffer overflows. We can also defeat these kind of, even if the buffer overflow existed, if you were doing a classic stack overflow and trying to smash the return address, you wrote a bunch of bytes over it, and now it's not tagged anyway. So even if you knew what to put there, it wouldn't matter. You now require an attacker now has to have some ability to mint interesting capabilities and put them in the right place. So the gadgets they need are much more complex, and we make things just generally difficult for them. So let's go next. I'm going to pull that up here. Presentation. And now I'm going to let John come up and talk about our idea for bringing CHERI into FreeBSD in FreeBSD 16. Yes.
All right, so that's a little bit about CHERI and what it does. But part of the reason that we wanted to talk to you guys today, or you all, is to talk about when does it make sense and about actually bringing CHERI support into FreeBSD proper. Currently, we maintain a downstream fork called CHERI BSD, but at some point, it's going to make sense to pull this up into FreeBSD itself. And we think the right time to do that is probably aiming for before FreeBSD 16 is released, which is a variable timeline, but that's kind of what we think. So why do we think that FreeBSD 16 might be a good target time to pursue this? First of all, CHERI is now a thing that's been proven to work across multiple architectures. We started on MIPS. We've abandoned that because MIPS. But it now has been, we've defined it for RISC-V, and ARM has built their Morello prototype architecture. In particular, on RISC-V, there's a lot of interest outside of just academia. There are currently efforts underway to define CHERI as an upstream ratified standard to RISC-V, and this is not driven just by folks at Cambridge. There's commercial interest from a couple companies, including Codicip, who's in the process of building a 64-bit design that will incorporate CHERI, as well as SCI Semiconductor, some of their principals worked on a project called CHERIOT, which applies CHERI to a 32-bit version of RISC-V, kind of targeted more at microcontrollers. But it is coming. It is going to ship at some point in the not-too-distant future. It's also true, so that's what kind of, I guess, the main motivation is the fact that RISC-V is going to ship. And in the current ecosystem of things that you're able to run on a CHERI processor, if you're not running an RTOS, CHERI BSD is the most compelling general-purpose operating system out there, the one that's most complete, that works with a pretty full stack. I know one of the things in particular about the demo we're doing today on Morello Box is that actually the whole thing, we're running, this is Ocular from KDE that's presenting the PDFs, and it's running as CHERI C, so full memory-safe graphical stack with, is this Wayland or Xorg? I think, well, they both work because we use Xorg for SDDM. But a fully built graphical stack with Qt and all sorts of things that all work when compiled for CHERI. So CHERI BSD is like the thing that's viable. And so as a result, because we are a fork of FreeBSD, that means FreeBSD is in a very good position to be kind of the best first of breed for supporting CHERI, if we take advantage of that opportunity soon. Because as there is industrial interest in CHERI, other systems, mostly Linux, are going to catch up. There will be a CHERI Linux in the not too distant future. And so we have a window of opportunity where we can be first, but only if we take advantage of it. So, if we're going to upstream, what do we mean by upstreaming? What do we plan to do? So the thing that we think makes sense to do first is just kind of general support for CHERI as an architecture. So what does this mean? This means the ability to have what we call pure capability, where all the pointers are capabilities, both in a kernel and a user space. One of the things so that requires just general changes, kind of the way you might think about having a new architecture. Not quite as bad as 64-bit versus 32-bit, but not about somewhat similar order of changes to support a kind of architecture variant. We also have a compatibility layer called FreeBSD 64, which allows you to run legacy 64-bit applications that used to use integer pointers, kind of like on 64-bit architectures we have FreeBSD 32. It's structured mostly similar to that. The things that we think make sense to target in terms of architectures for upstreaming is the standardized CHERI RISC-V. So right now we have the kind of internal version we developed at Cambridge for research, and it's not quite exactly the same thing that will land as the ratified standard. And whatever ends up being ratified, that's what's going to make sense to upstream. One of the things that goes along with that, of course, if you haven't already asked yourself, is tool chains. And we anticipate that support for standardized Cherry RISC-V is going to make it into upstream LLVM, along with kind of the general support for Cherry as a notion that's needed in LLVM to support that. We don't know exactly the timeline for that in terms of will that land in time for FreeBSD 16 or not, but eventually we will be able to use an entry toolchain to support Cherry RISC-V. On the other hand, we also think that at least in the near term it makes sense to support Morello. Now Morello is not a part of ARM's architecture that they're committed to supporting in the future as a standard extension. It is a one-off demonstrator, but it is also, in terms of physical SAN, the most practical Cherry instance to use, because it's a real processor that runs at 2 point whatever gigahertz, and there's 4 CPUs in a package, which is much nicer than using emulated things on the FPGA, or even the early RISC-V designs are not going to be quite that beefy, right? They might be looking at something that's more like a Raspberry Pi. So I think for near-term use, Morello Box is going to be the most comfortable experience for folks to get used to. But some one caveats about that is because it is a kind of demonstrator fork of ARM's architecture, there's not going to be support for Morello in an upstream tool chain, and supporting that architecture is going to require it to be using an external tool chain. Also, it's our belief that Morello support would be a tier 3 thing, because if ARM decides to ship a real Cherry extension in the future, it will use different opcodes, and it will be a hard, like ABI brick and so forth. But in terms of the source code, we'll be able to reuse most of that, we believe. But we wouldn't guarantee binary compatibility across such a change. And tier 3 is the get out of jail card to let us do that. Another thing that goes along with, a lot of what we talk about here deals with user space, but it is true that, as I alluded to KDE running, we have some patches to ports that will also be something we would like to upstream in parallel with moving things up to source. So phase 1 gets us basically a working Cherry architecture. It would allow you to run spatially safe C on, for example, Morello Box with a full desktop stack and so forth. But there are things beyond that, some of whom we'll talk about later, that we think might make sense to do in later phases. And part of the reason we want to do later phases is we know this is going to be a big ball of mud to review. We're well acquainted with how big the ball of mud is. And to the extent that we can make phase 1 as small as we can to make it at least somewhat digestible, we want to defer other changes that happen to later phases. And some of these we'll talk about more, something called subobject bounds, and heap temporal safety that Mark's going to talk about, we think are additional phases, and other things that we're continuing to research on, like compartmentalization. As they continue to mature and reach production grade, then we think those will make sense to upstream. So, what are some things we aren't upstreaming? If you go to GitHub and you figure out the right incantation or branch names to look at our diff, it is huge. And a lot of the things in that diff are kind of ugly, and we know that it's ugly because we worked on it. And some of that is a product of the fact that Cherry has been a thing that has been developed over a long period of time. Are we up to 15 years at least, something like that? Approaching 15 years? That's a lot of development, and we've had to learn a lot of things. Early days before I started working on Cherry, we didn't have a compiler that could compile what we call Cherry C, and things had to be done by hand when you wanted to manipulate capabilities. And so over time, CHERI BSD has evolved as our toolchain and our kind of familiarity and knowledge of the architecture has evolved. And so we've learned some things. But we have some artifacts of kind of the ways we've done things in the past. So one big one of those, Brooks alluded to, is that we started off not being able to use full Cherry C in the kernel. We allowed user space pointers to be capabilities, so we could enforce spatial safety on user space and honored that when arguments were passed to our system calls. But we didn't do it in the kernel right away, and that allowed us to have a kernel that ran so we could focus on doing research in user space, because it's a lot easier to change things when you have a working kernel under you and you can still debug things. But that entails supporting the fact that user pointers are a different size and shape than kernel pointers, requires a lot of diffs. And while those have been useful for us in our development, we don't think any of that makes sense to upstream. And in fact, our rough estimate is somewhere between 1/2 and 3/4 of all the patches we have in the kernel are to support this alternate kind of ABI for the kernel where it's a mix. And for upstreaming just a pure capability kernel, we won't need any of that, and then it will be a lot more straightforward. So a lot of things you might see in the diff are not going to come upstream. So don't look straight at the diff and get scared. There's also some things in our kernel, or our diff rather. Some of them are maybe vestiges of things we haven't fully purged. I'm sure we have some of those. There's definitely things we have purged, but we probably missed some spots. And then also, we are doing ongoing active research into things. And so some of the things we have in our tree are perhaps less mature than others. And so we're not planning to upstream things that are still kind of actively under research, and we're still figuring out how they will work or if they will work. So what does it look like, kind of now thinking, if you're kind of a FreeBSD developer, what does it look like to have a CHERI architecture in the tree? What are some of the implications? So one thing Brooks already alluded to is that for each platform, you end up with a new machine arc. And so we basically take the base machine arc and we add a C suffix. So ART64C or RISC-V 64C, that denotes the kind of CHERified version of an architecture. So just like 64 and 32 have different machine arcs, the same is true with CHERI. It's kind of like a new class of CPU architecture. So we have a whole new kind of concept of ABIs. Today in FreeBSD, our architectures are generally split into two camps. You have 32-bit architectures where integer longs and pointers are all the same size, and LP64s are 64-bit architectures where our longs and pointers are 64 bits. And CHERI is a new version of that. So in CHERI, your long is still 64-bit, but your pointers are not. There's this 128, really 129-bit thing. So you have to think about kind of a whole new top-level class of sizes are. And we have a reference, you can follow that link. We've patched the arc.7 man page in CHERI BSD to add these new architectures and kind of update some of the tables to reflect the different properties of CHERI architectures compared to existing ISAs. In terms of C types that we use in the base system, we have some new types and we have some types that maybe have somewhat different semantics than you might be used to. So uint pointer T has to be able to round trip a pointer. That's what C says. So uint pointer T in CHERI is a capability, meaning it's got the 1-bit tag on the side and it has the upper word of metadata, which means it's not just an int. So it's not just a plain int. It is bigger than an int. So for example, it has more bits than a uint max T because a uint max T is only designed to hold scalar types, which are integers. But there's sometimes when you don't need a pointer, you need an address for certain things. And so we add a new kind of base type called pointer adder T, which is when I want to work with just an address of a thing and not necessarily I need the full pointer of a thing, so that we can kind of distinguish when you want to deal with one of those use cases versus the other. So where are some places in the tree that this kind of distinction where pointers and addresses are different types we run into? So elf adder in places like the runtime linker, or the way we handle relocations in the kernel, for example, we like to basically assume we can convert elf adders into pointers into lots of places, and we can no longer do that in CHERI. So we have to change them either to be uint pointer T or to be a real pointer to deal with. Things like TLS allocation is another place where we have a bunch of diffs and RTLD that basically are dealing with this fact that elf adder is an address, not a pointer. Similarly, in the kernel, we have this wonderful type called VM offset T for mock that we use all over the place. And VM offset T we treat as an address, and so there are some places where we need to change those to be a pointer. So currently in CHERI BSD, we've introduced a new type of VM pointer T, which is an alias of uint pointer T in effect, and patched various places to use that when they actually mean a pointer that the kernel is going to treat as a pointer. So aside from types, what are a few other kind of C idioms you may be used to using in FreeBSD that get spelled a little differently or they have slightly different semantics when operating in a CHERI context compared to a traditional architecture? So one is that CHERI capabilities have a tag, as Brooks alluded to, that decide how do we decide when a capability is valid? You can still use it as reference memory versus when it's not. It's been corrupted in some way or someone's tried to inject one over the network or something crazy. So we have a notion of when do you need to keep tags and when do you maybe explicitly want to throw them away because you're handing memory off to somebody you don't trust and so you want to throw the tags away, which means that in some APIs we have to be aware of when do we want to keep a tag around and when do we not. So memcopy preserves tags, meaning if you copy some structure or something that has pointers inside of it, in the destination copy, the pointers still work, because if we broke memcopy, then C would be broken. So we have to keep copying pointers work. But there are times when you may want to do a memory copy where you know it's just scalar data, or you know that the pointers you copy you want to not work, and whoever you're handing the pointers off to. So we have an extension of memcopy called memcopy nocap that will strip tags in the destination buffer of any pointers that it copies. And then we have a couple of similar changes to other kernel-specific APIs. So copy in and copy out and kind of that family of APIs for dealing with user memory, they have extensions to deal with capabilities. So you can choose when you're copying a structure in from user space whether or not you believe the structure should have pointers or not. And if it shouldn't have pointers, then you'll just use copy in. But if you actually need pointers because you're copying in some struct that has nested pointers you're going to chase, then you have to change your code to use copy and cap to say I want you to preserve those tags because I'm getting a pointer, I mean it, I'm aware. We have, for example, this isn't an exhaustive list, but some other types of things. For UIO move, there are a few cases, and SCSI CAM things, where UIO move insists on copying in blocks of things that have pointers inside of them. So, and also there's some ptrace cases where this happens, if I remember correctly. So we have a way when you are constructing a UIO that you can say, I don't want you to just do a read or a write, I want you to do a read or a write that preserves tags. And then another ball of mud is ioctl, which we have the sad face because we cry about ioctl in many ways. Conceivably, we could find a scheme where we tag ioctls to say this one has pointers or not, but we haven't done that yet, and so currently ioctls just always preserve capabilities in the initial copy in that they do in copy out. Some other things that you have to deal with when you're working with CHERI is CHERI pointers, the way tags work is tags are only valid on kind of a pointer-aligned boundary. So CHERI capabilities have to be stored on like an aligned boundary of a pointer for the tag to still work. So this means you have to take that into effect, that the compiler may need to insert extra padding than it would otherwise because you've misaligned a pointer in a struct of some sort and the compiler is going to fix that, but you have to cope with that. If you've written your own allocator and you have to take into account the maximum alignment you have to do, which now we have a new type in C, maxalign T, that handles that. But a lot of code, older code, has their own maxalign T, and they don't have a pointer in the union they use to define maxalign T, and so it doesn't work on CHERI, and we end up with misaligned pointers that don't work. Pointers are also bigger, and that comes at a cost. Like that adds overhead just like it did for 64 to 32-bit. And you have to be intentional about using types that really are, for example, unit pointer T. I kind of alluded to this when we talked about LFAT or VM offset T or perhaps long. Other types that on our current architectures, they actually will work to hold a pointer, but they won't in CHERI. Another example of this is it's a common theme in some things like ZFS and some other places that the way you solve the 64 versus 32-bit problem is you just use a uint64t because that's big enough for pointers and all your structures that you pass around in ioctls and system call arguments and things, because that's big enough to hold a pointer everywhere, except on CHERI where it's not. So those are some of the things you kind of may have to deal with when looking at kind of CHERI and FreeBSD's context. So one more kind of, I think this is the last topic I have to cover. So in phase one, we talked about just having kind of base CHERI support. But one of the things that CHERI allows us to do is if you're willing to kind of break a little bit more of C and require a little more care, you can kind of do some more creative things. And one of the things we've played with that you can do to gain a little more protection is something called Subobject bounds, which is the ability at runtime for the compiler to decide to narrow bounds to a member of a structure or union, or perhaps an element of an array instead of the whole thing. And this can be some nice properties. So Brooks wrote an example here where we have a structure, and it has a char array right next to a pointer for a function. So in a traditional architecture, if you overflowed the char array, you would get to override a pointer and maybe retrieve arbitrary code execution because now you can redirect the pointer to where you want to go when you override the array. And in base CHERI, we're going to apply the bounds to the whole struct foo. So we also don't protect against that. I mean, we protect against that because you can't, when you do the overflow, it's going to be untagged, and so you'll die because the pointer you write is corrupted. But we can't prevent you from writing to the pointer necessarily. But if we turn on subobject bounds, then if you pass, for example, foo data as an argument to memcopy, the pointer that memcopy gets inside is actually constrained to the array, and you can't overflow out of the array into adjacent things in the structure, which is the example that Brooks has here in update foo. So one of the things we have done in CHERI BSD is we have play with this a little bit in some user space components, but it does break quite a few things because there are things in C that want to kind of narrow bounds and come back later. In particular, you can think of the way you would do OOP in C, where you might embed a base class as a structure member in a larger structure in a superclass or a subclass. And then when you want to do the downcast, you're expanding your bounds back out again. And that doesn't work if you turn this on. But we have found that we've been able to actually do this in the kernel and have it work. We do have to do some annotations, but we have some ways the compiler can tell you. For example, if you use container of to kind of deal with your downcast, the compiler will warn you at compile time if you haven't added the annotation to the right field to make sure we don't narrow bounds when you do the upcast. So this is something that we think might be something we could upstream as our phase 2, and it gives you an extra layer of protection that you can't get with things like address sanitizer. And this may be a way of stretching C even more. All right, so the next one, I'll not preview it, I think goes to Mark. Sign over to Mark. That'll work.
Okay, is this, all right, I can hear myself. So another feature that CHERI enables with some additional assistance from the operating system is Heap temporal safety. So in the code example that I gave on the top left, there's pretty routine C programming bug that can have security implications if this pointer to a struct foo is allocated as some other type of structure before that increment happens. So at that point, we have a pointer to, a dangling pointer that is now being used for something else, and these kinds of bugs can have security implications. In fact, they're quite common, just as much so as buffer overflows, which we saw are mitigated by CHERI C's spatial safety guarantees. So it turns out that with some machinery, again from the operating system, it's possible to mitigate these types of bugs as well. So to think about a few strategies for this, or present a couple of examples. One strategy for avoiding those kinds of bugs is to just never free memory. If free is an OOP, you leak all your memory, and you never have a use after free. That causes security hole. So that works. Obviously, it doesn't work very well for long-lived programs. So the other thing you can do in CHERI is basically scan a process's whole address space. You can look at every single piece of memory that's mapped into it from the kernel, and for each 16-byte aligned chunk, see if there's a capability tag associated with it. And so one thing you could also do is, after calling free, scan all of your memory, look for pointers into the buffer that you're freeing, and clear the tags on all of them. And then free returns, and you keep going. And then after that, this attempt to increment A will just crash because it'll try to dereference a pointer that doesn't have a tag associated with it. And that works too, but it's very expensive. So in CHERI BSD, what we do is basically take the second approach and try to amortize it across a whole bunch of allocations. So the key property that we're trying to preserve is that use after frees are still possible in the sense that you can dereference a pointer after you've freed it, and it might work or it might crash, but you can at least guarantee that that buffer won't have been reallocated for some other purpose. So in particular, we distinguish between use after reallocation, in which a dangling pointer is used to access memory after that memory has been reallocated for some other purpose, versus use after free, which is just accessing a pointer to a buffer that's been freed. So use after frees are still possible. They won't necessarily crash your program, but we can turn use after reallocation into a deterministic crash instead of a potential security hole. So like I said, the approach is to basically scan all of memory, look for pointers into buffers that have been freed, and clear the tags. So to do that, there's some support required in the memory allocator as well. So normally a buffer has one of two states. It's either free or in use. So in CHERI BSD, there's a third state, the quarantine state. So when freeing a buffer, what we want to do before reusing it is make sure that there's no dangling pointers that reference that buffer anywhere in the process's memory, in its in its registers, thread registers, nowhere in the kernel, maybe the kernel's caching pointers, basically looking through all of those possible places where a dangling pointer can be squirreled away and clearing all those tags. At that point, it's safe to reuse all of those buffers because the worst that's going to happen is you're going to get a deterministic crash. So there's quite a lot of bits that are required to make this work. It doesn't come for free, like with the notion of CHERI capabilities like you get with spatial safety. There's some extra support required, as I said, in the memory allocator. So the actual pieces I've kind of tried to enumerate on the left side. So in CHERI BSD, we have something called MRS, which is malloc revocation shim, which is a layer that interposes between application code and malloc and the rest of the other memory allocation functions. So what it does when it receives, like when a pointer has been freed, a pointer to a buffer has been freed, rather than freeing it to the underlying allocator, that pointer goes into basically a linked list of quarantined buffers. And at some point, when the amount of quarantined memory grows large enough, we use a system call called CHERI revoke to initiate that revocation pass that I described, wherein we scan all of memory, clear tags to quarantined memory. So as you can probably imagine, locked. There we go. Scanning everything is pretty slow. And so in the interest of, minimizing, I should take a step back. There have been a few different designs which solve this problem, but I think the paramount, consideration is application latency. If free suddenly, most of the time takes a few microseconds and then suddenly starts taking half a second in order to complete because in the background it's doing a big scan of memory, that's not very good. So successive designs of this heap temporal safety mechanism have aimed to reduce that latency. So in particular, we have the system call which does background scanning, but we also do scanning in the foreground. So once you start a revocation, once you start trying to clear dangling pointers to quarantine memory, another thing that happens is that all attempts to load a capability into a register will trigger a page fault into the kernel. And what happens there is we can, when handling that fault, check the memory that's going to be accessed and preemptively revoke any pointers in there. So scanning a single page versus the file address space, that's much cheaper. And we only have to do it once when processing a particular page per revocation pass. There's also, and so as I mentioned, the memory allocator maintains this quarantine state. It also maintains a bitmap which it shares with the kernel. So you have effectively 1 bit for every 16-byte chunk in the program's address space. So 1 bit for every 128 bits of virtual address space, so less than 1% virtual memory overhead. And a lot of that never actually gets allocated because most processes don't use much of their, or they don't use a significant fraction of their available address space. So there's a bit of memory overhead there, but it's quite small and basically in line with traditional metadata allocator traditional allocator metadata overhead. So there's what we call the load side revoker, where processes which load capabilities into registers, clear them by trapping into the kernel. There's a background scan which makes sure that everything else gets cleared. And to enable that, we have a few extra extensions to page table entries, which basically reflect whether a given page or a given virtual page has been scanned or not, and certain knobs that you can use to control MRS. So historically, that background scan triggered by the CHERI revoke system call was synchronous, so it's very expensive, but we've recently made it asynchronous. So there's there's environment variables and syscontrols which control that. I said in the very beginning, we could, after every single free call, scan all of memory, clear all of the dangling, or clear tags for all dangling pointers, and it's actually possible to enable that, because that does give you deterministic use after reuse checking. Because again, in this example, it's possible for that access at the end to trap, or it might just access memory that's still in quarantine. in which case you don't necessarily detect it. And finally, there's a few pieces to handle what are called kernel hoards, where again, a process might have a capability that's stashed somewhere in the kernel in some state that's maintained by the kernel. So KQ is probably the easiest example of this. When you call kEvent, you fill out a structure, a struct kEvent, and there's room in there for user space to stash a pointer. So, it's possible that user space would stash a dangling pointer into a kEvent, call into the kernel, scrub it from its own address space. Well, in order for this whole mechanism to work, CHERI BSD also needs to scan all of those kEvents. And there's quite a few, there's a number of different kernel interfaces which let you do that. So there's some glue which connects the CHERI revoke system call to those different subsystems and clears tags for dangling pointers. So I'll just give a quick demo of this. So a slightly more elaborate example, but basically the same as what we do in the slide. We allocate a single character, write some data to it, free the pointer, write to it again, and then call this special malloc revoke function, which is part of MRS, which effectively just does a synchronous revocation before it returns. And then right after that, we have a printf, which again dereferences that pointer. And so after that malloc revoke call returns, that access is guaranteed to trigger a tag fault, because that pointer CP ought to have its tag cleared. It's possible also that the call, or that the access immediately following the free would also fault. But in our implementation, it's basically, it depends on how frequently revocation is actually happening. So one way or another, we expect this program to fault. And indeed it does. So more specifically, you can see that it faults when accessing that pointer following the malloc revoke call. So in particular, that use after free immediately following the free call is not caught. But this one following revocation is, and that effectively mitigates those dangling pointer security vulnerabilities, just because it's relatively innocuous to access a pointer that points to freed memory. It's still a bug, of course, but those bugs turn into security vulnerabilities once that memory is reused. So it's possible to enable a mode where free will effectively have the same semantics as malloc revoke, but that's too expensive to enable by default. I believe, I think Jessica's actually booted a system with that enabled, and it's still usable. It's a bit too slow, but not to the point where it's catatonic. It still boots up. One more section, on compartmentalization. Still need this? Oh, yes.
I will talk briefly now about some very much in progress work on fine-grained compartmentalization. So one of the promises of CHERI is that by building on top of the memory safety that CHERI provides, we can create extremely fine-grained compartments with extremely fast context switching. The intuition behind this is that the portion of memory in your process address space that you can reach is the transitive closure of your register set. So all the capabilities in your register set can reach some other capabilities, or can reach into memory. That memory may have capabilities in it, et cetera, et cetera. That doesn't have to be everything in your address space. So you can, with a tiny bit of hardware assistance to enable domain switching, switch between compartments which can access different data within a process. And you don't have to enter the kernel. You get to share your TLB. It's just much more efficient. So we've done a number of prototypes, but the most recent thing that we've been working on started out as library-based compartmentalization. In the library-based compartmentalization model, we start with the hypothesis that the software engineering boundaries for libraries are a sensible security boundary. On a future slide, I'll tell you that's not true, but it's a pretty good approximation, and it's how the code's already cut up. Because one of the problems with compartmentalization in the past has been that it's a lot of work to take a program and sort of rip it into pieces to do different things. So we see it only in the most critical applications with the highest attack surface. We see it in OpenSSH with privilege separation. We see it in Chromium, Firefox, Safari. So other cases, Mac OS and iOS have pulled bits out and stuck them in processes because that's all you got. But you can only do it when it's really critical and when the performance impact is small. Because if the performance impact is huge, it doesn't matter how critical it is because no one will use it. So what we're doing here is we have a demonstration here of library-based compartmentalization, and I'll give you a quick glimpse at what that means. So we have this ocular process here. Yes. So here I've used the C18N, which is short for compartmentalization, because that's too long to type, and I misspell it half the time anyway, so it'd be really bad. It is, so we're showing here of interest. This is the ocular that I was displaying the PDFs in. There are 147 compartments, and they're also, due to threading and whatnot, there are 1,200 stacks, separated stacks for different threads. Let's see. Let's do the more interesting demo. Here's our list of compartments. We've got the runtime linker. We've got a couple libraries grouped into the trusted computing base, TCP. There's the unwinder, and then the program, and then a gazillion KDE libraries. The other thing that Robert likes to do in his demos, let's set a breakpoint on PNG. There we go. We hit some. I caused it to render a PNG, and now we are at a breakpoint, or no, we have set a breakpoint. Oops, I set a lot of breakpoints. That's right. Now, let's continue, and let's pop up ocular and move it around, try to move it or something, and then, today? No. Oh, yeah. Here we go. We hit one. Now, backtrace. All the GDB fun is John's work. And if you look down near the bottom, you'll see a cross-compartment call here, where we have called from one to the next. And there's another one here. So you can see we're isolating each of these libraries in its own sandbox. And so, yeah, that's that. Let's quit out of, ooh, that was exciting. Let's go, quit. Let that run again. So, yeah, that's sort of the quick and dirty demo. And let's go back to the last bit of the presentation. So that's library compartmentalization. As I said, the initial hypothesis is that the software engineering boundaries are sensible security boundaries. There's some obvious cases where that isn't true. For instance, if we think about libc, libc does all sorts of things. It has 1,000-odd symbols. It has surprise, printf can trigger DL open to load internationalization bits or localization bits and whatnot. And yet it also holds capabilities that can access all the heap memory in the process because it has capabilities for every capability returned by mmap to malloc. So we'd like to keep those well isolated. So we'd like to, for instance, be able to put a compartment around malloc. So one of the things we have work in progress is to add compartments within libraries. This is a bit of linking change, which you can pester John about, because John's working on it, on one of our two efforts. But the idea is to be able to, based on a policy, group code and data together within libraries, create little sub-libraries, and add, and then adding per component GOTs and PLTs so they can be compartmentalized. And so we're going to go from 150 compartments to who knows how many. The DARPA CPM program, that Compartmentalization and Privilege Management program that we're currently working on, has groups working on automated compartmentalization, discovering where this compartment boundaries should be. And so we'll see where we get in terms of total number, certainly thousands or tens of thousands probably. It's worth noting, I don't remember the command sequence to do it, but you can see in the system with PMC stat that if you're running with all the system compartmentalized, we are taking on the order of 1 million compartment transactions per second, and from a user perspective, there is no impact. And that's just completely inconceivable with current process-based compartmentalization technologies. So this is stuff that is very much research. We sometimes turn compartmentalization on for the whole systems, and sometimes we're scared and we don't. For a demo or something, but we're getting close there, and it's something we hope to bring to FreeBSD eventually, but it's definitely well down the road. It depends on the spatial safety and on heap temporal safety, and probably some more enhancements to that heap temporal safety that we haven't implemented yet. So some work there still to be done. So I'd like to invite you to get your hands dirty with CHERI if you're interested. We have CHERIBSD.org. You can learn about CHERI BSD. It also has the installer if you get yourself a Morello box. You can look in CHERI BSD ports for the sort of changes we've made. I will caution you that the current ports tree is over a year out of date. We'll get caught up soon, hopefully. But we've had other priorities. However, the CHERI BSD ports collection that is there is what built all the software that's running on this system. So we have, our modified LLVM in Clang, which is not a pure capability program yet, but the PDF viewer, KDE, and all those bits are pure capability. There you can download CHERI build, which is a giant and scary ball of Python. But the important thing about it is it lets you build CHERI BSD, the compiler, QEMU, GDB, all that good stuff, all from one command. And you can do that on FreeBSD on your Mac on a Linux box. And more or less, it's one command. There is a link here to the dsbd.tech website. This is a UKRI-funded project that is what funded Morello. And you can request a board for your company if you're interested in using CHERI at your company or exploring it. You just have to answer some questions and they will send it to you. You don't have to be a UK company. It is definitely possible to get them outside. And then I linked to our very, very preliminary, taken off of a whiteboard last week, upstreaming tasks list for FreeBSD, just trying to put together the list. There is a selection of tasks there that does not require CHERI at all. Probably requires a bit of knowledge of CHERI, but some cleanups and refactoring that will help the process along. So that's what I've got. Does anyone have questions for any of us? You can hand out the mics if so.
Actually, do you want to sit?
Sure.
Oh yeah, you have to take it out of take the thing off the top and get it on. You have to take it off, yeah, sorry, it slides out and there's a button on the bottom.
So at this point, between the hardware and the software, roughly what is the overhead of the CHERI protections for various workloads?
It's a complicated answer. Depends on what kind of workload you're running. So there will be workloads where you see essentially no overhead. There'll be workloads, most of them probably fall in the sort of sub 5, maybe a little over 5% cycle overhead. If you're running a particularly pointer dense workload, then you can expect to see higher overhead just from the additional memory pressure induced by the pointer size. So for example, language runtimes would probably be something that are disproportionately affected. I think those are something that we've not properly benchmarked so far. The thing we focused on historically has been spec CPU 2006. And for that, we see, or we estimate based on numbers from Morello that it's about 2 to 3% is probably achievable as a mean across the benchmarks for that suite. But it's going to be very workload dependent. If you get a Morello board and you start benchmarking on it, there are a lot of caveats for the implementation on Morello specifically. We have a report on this, but due to various constraints in the timeline of the development, the hardware doesn't quite have the performance one might expect of something that's production ready. So you can see disproportionate overheads there as well. But we've been able to extrapolate a more realistic number from that.
A quick question about the upstreaming to the FreeBSD project. So as of the FreeBSD 16, we will have a new ABI called ABI for the CHERI architecture. So does it mean we have same change for the non-CHERI platform or just for the CHERI supported platform? We will have
So there are certainly code changes that are common, or changes that affect parts of the code that aren't specific to a CHERI architecture. But in some cases, you're still on the type differently in a way that doesn't matter on a non-CHERI architecture. So for example, if we decide to upstream VM pointer T in places instead of VM offset T, those types are the same type on a non-CHERI architecture, so it doesn't mean anything for non-CHERI architectures, but it will be a change in the source code. There are a few places, Brooks mentioned one when he talked about UIOs. There are a few places in the kernel where we have an allocation. We do a couple of these in early startup where we'll allocate two different things that are kind of very different sizes, but we'll do one giant allocation that has both of them. And that's kind of problematic for CHERI to kind of have a nice pointer that's representative and doesn't require excessive padding, where they're two separate objects anyway, and they eventually even get stored as two separate pointers in the kernel. And we'll actually do two separate allocations during startup instead of one. But those type of things are not going to be meaningful or measurable difference-wise on non-CHERI architectures. And it's like a few lines of code to change something that instead of one big grab in pages, you grab first, X and then N minus X 2 lines later. But I can't think of any large-scale changes that will really impact non-CHERI architectures in a visible way or performant way that you would be able to measure or observe.
So at the source code level, we will have new primitive for CHERI even on the non-CHERI platform, right? It will be non-op or something.
It is true that we mentioned earlier, or Brooks mentioned, that we have compiler intrinsics for when you need to do things specifically to a CHERI capabilities, such as when you're inside an allocator like malloc, and you need to narrow the bounds on the bigger pointer from mmap or something to the smaller pointer you're going to return to your caller, so they have narrow bounds. That requires a line of C. That's going to be a stub that compiles to nothing on non-CHERI architectures, but it will be a source code visible change that we do need to honor things like bounds in some places. Inside the kernel, vmem is the thing we currently use to manage address spaces for memory. And vmem inside of CHERI BSD needs to be aware of capabilities, both that it needs to be able to narrow bounds when necessary, but understanding the padding and alignment requirements, so that if a vmem is doing an address space that's going to be used for capabilities, because some of them aren't for device drivers and things, we have a flag to say, well, then you need to take into account whatever padding and alignment you need to do, so when you're doing allocation, maybe you need to line it, round the size up a bit bigger, make sure it's suitably aligned, that the pointer you return is valid and doesn't alias anything else around you. So there are some changes in a few places for that. But in many cases, I don't know that they will impact non-CHERI architectures. It's certainly not performance, but it's even not too much in code. Like you'll have a line in something like KVA alloc maybe that needs to set bounds if it doesn't already get it from vmem. But you're not going to, it's not all over the place actually. Even in application stacks, you tend to change the internals of malloc or the internals of maybe the runtime linker because you have new relocations to deal with. But you don't have to change things that call malloc. Things that call malloc just get a pointer and they're happy. And the same thing is true in the kernel. Now, one of the things we are looking at maybe changing upstream, I've done some of it already in some changes recently, is there are places where we like to use integer types like VM offset T when we really need a pointer. And then in fact, we actually have to do a bunch of casts. So I think recently I changed some PMAP things. I don't know if I upstreamed them yet, like PMAP mapdev, I think is one I changed recently, where traditionally that returned a VM offset T, and so everybody immediately cast that to a pointer in all the calling code, and then when you wanted to call PMAP mapdev, like on mapdev, you had to take your pointer and cast it back to a VM offset T. And when I changed those to be void star instead, what really happened is we got to remove a whole bunch of casts throughout code in the kernel, which was just ultimately cleaner for everybody. And I think in some cases, the changes that we will make as part of upstreaming will be more along the lines of that we're going to try to do things where maybe we're just a little bit cleaner about distinguishing when we actually mean pointers in the kernel rather than an integer that happens to look and be the same size and shape as a pointer.
Okay, thank you.
So FreeBSD 15.0 is going to happen sometime around November or December of 2025. FreeBSD 16.0 release sometime around November or December of 27. So when you say you're aiming for FreeBSD 16, do you mean September of next year when we we have 16 current, or do you mean summer of 27 just before we branch stable 16?
So I don't hate you, Colin. We don't hate you collectively. So we're not going to do September of 2027. So I think we talked about upstreaming this week quite a bit. We kind of built out a roadmap of what we think it looks like and some kind of stages we can get to. And certainly there's some cleanups, changing some more things to use void star in the kernel, for example, that we can do that are cleaner for everybody and we can do sooner. We hope to do those sooner rather than later. I want to also, I think it's useful for us because we talked a little bit about this notion of how we kind of evolved our kernel over time, and the fact that we did a hybrid kernel meant we had to have a lot of diffs. And we actually have a bit of a research question we want to answer for ourselves, which is, well, how bad would it be if you didn't do that? Or kind of like, what is the actual cost to cherify a kernel if you're just doing kind of the normal, treat it like a new architecture thing? And so to some extent, I think we're going to run the science experiment of having a Git branch where we kind of get it all up and running well before we upstream. And so we're going to be doing that much sooner than the timeline of 16. And it may not surprise me if we end up actually having some bits that make it into 15 perhaps, 15.0 current, but not as a thing that gets released, just because of how long it's probably going to take to get things like this reviewed and upstreamed. But I don't think we are at all planning on trying to cram it all in 2 months before the release. I think we are viewing the 16.0 as we're trying to give ourselves enough of a runway that we have quite a bit of time to try to merge things up, and we know that we're not going to merge it all at once as one giant monotonous git commit of doom. So we're trying to give ourselves enough runway to see how much we can split things up. What are the smallest possible things we can do that maybe even early on it doesn't all compile yet because you have part of the architecture and not some bits that come in later, for example. We're trying to give ourselves enough room that maybe a lot of it might be there in 15, but not fully or something like that. But we're trying to say that we think will all be there in something you could actually have a releasable product that ships in 16. That's kind of our goal. Anybody else want to say?
Yeah, I would say we probably want to be in by, 2020, the end of 2026, if we can manage it. Certainly the basic functionality in by that time would be great. We also, we have the ability, for instance, to, focus on the kernel first, and you could run CHERI BSD user space potentially, and we might do that. It's really going to depend on who's available and how much time we have, what exact strategy and how much parallelism we're willing to employ. There are a bunch of minor user space changes that, for instance, could come in at any time. For example, init uses Berkeley DB as an in-memory hash. It aligns pointers at 2 bytes, which makes CHERI very cranky, so we have to replace that. There's a few other, there's a bunch of other little fix-ups. We need to replace our merge sort implementation, some other stuff that is like a separate task. And one of the things we've broken out in that GitHub project that I linked is the stuff that's not really CHERI. It's a requirement for CHERI, but it's just a change. It doesn't require knowledge of CHERI. We could definitely use some help on some of these things. We also, when I did FreeBSD 64, I took the FreeBSD. It's all derived from FreeBSD 32. Very little that's not just a straight up copy. Except that I did some refactoring, and the amount of duplication offended me, so I made some changes to add another layer of indirection and have less duplicated code. But also, I didn't like the 3,000 odd line FreeBSD 32 MISC file, so I broke it up by subsystems. It'd be nice to do that to FreeBSD 32, so that we can then copy that and splat FreeBSD 64 on top of it, and at least the history will look sort of sane. Or at least have the not so bad. So, a bunch of things like that. Yes?
thought about ways on how to bypass this?
Ways to bypass CHERI?
Yeah, like, in back, there are ways where there were issues with the compiler. I'm just thinking about like, it's really cool, but what is the threat model? Like, what are the ways you can think of bypassing this as an attacker?
Well, so the compiler is part of the trusted computing base, as is the runtime. So malloc has to put correct bounds on things. The compiler has to put correct bounds on things when it passes a reference to an automatic variable or something like that. But you have to be pretty wrong to get things wrong there. And also, unlike, say, PAC, CHERI is deterministic. There is no way, in at least the ARM architecture, to generate a sequence of instructions that creates a capability which has higher permissions. And that's a formally proven property of the architecture. Now, whether an implementation correctly implements that's a different question. And there was a recent nice study, who did the Chariot verification? Oxford did a verification of the Chariot design where they found a number of cases where the architecture wasn't correctly implemented in the microarchitecture, but they were able to find these things and fix them. Okay, and they have proved that it's fully correct now. So that is within the realm of the possible, and I think within scope of certainly many customers.
Is there the bounds which are kept in the pointer itself? Is that protected by the hardware itself, or is it? I'm just thinking, like, if there is a weak link, is it still possible to like change the upper 64 bits? Does the hardware allow you to like not change that at all?
If you write bytes to the capability through an instruction that is not a capability manipulation instruction, the tag is cleared in the register. So if you or in memory.
And DMA clears tags. Yeah. DMA clears tags too, so you can't inject them over DMA round trips, for better or for worse. I think also your question actually is there's probably a few PhDs in figuring out how do attackers respond to a CHERI-aware system and how do they do that? One of the things we've run into in some prior DARPA programs resolving around evaluating security architectures and how they deal with CWEs is that their tests had buffer flows in them that we broke before they even got to the point of running their real test. Because it is quite different. I mean, we are not naive to think that this fixes all class of bugs. It's in part why we really have a lot of hope for compartmentalization and the fact that you can constrain the resources or memory address or however you want to think about it available to an attacker once you break into a compartment of a CHERI system. And we're hoping that that is kind of the layer of depth of defense that will help protect it in the future of whatever unknown classes of attacks arise. But I do think that it'll take a little while for attackers to adjust and figure out how do you respond to this when kind of the easy current low-level hanging fruit doesn't work anymore.
Yeah, the Microsoft security response team did an analysis where basically or sort of a pencil and paper analysis, where they basically chopped off different security. They said, okay, so what if this part of CHERI wasn't there? What could we do? And they went through that exercise, and they have a published report on that, of sort of what the various pieces are. One of the things we changed in our architecture, we took an experimental feature that are called sealed entry capabilities. One of the features I didn't talk about is that you can seal a capability, which means any change to it clears the tag. And with a sealed entry capability, the only thing you can do with it is use it as a jumper call target. And one of the things they found is that in their study is that those made their life really hard. So we made those into a non-experimental feature of the architecture as a result. And they're used for all return address pointers. And also we use them for all functions in the GOT. So your vocabulary is quite restricted. It's not to say there aren't ways to, attack the people are going to want to attack RTLD and get those highly privileged capabilities, figure out how to leverage that, but you've got to do that.
Yeah, just to check the understanding, and maybe it's kind of connected to the previous question. Where are the tags actually stored? They are stored off-band, no, I guess?
They are stored off to the side. It depends. There's implementation choices, but they're not addressable like the rest of memory. Either the memory controller hides them one way or another. You can put them. You can stripe your memory in 129 bits, and the memory controller does the right thing. You could also have a separate tag cache, which is what we did initially. It is a suitable approach for some types of microarchitecture. I don't know how you make that decision because I'm not a microarchitect.
I believe it's correct that Morello is currently, the way we use it, storing them effectively in ECC bits, or what you might think of as ECC bits. And it's maintained, so the entire cache hierarchy has to be coherent and atomic. So anytime you're manipulating a capability anywhere in the cache hierarchy, it has to be atomic, just like for any other kind of atomic word.
As I remember, ARM produced hundreds, if not thousands, of ARM Morello board. So my question is, do we know where they're all gone?
Well, I know UKRI has quite a few sitting in their warehouse, or I think maybe the ARM has them in their warehouse waiting for UKRI to send them somewhere, so you should ask for them. It'll make ARM happy. There's also some number of chips left, but I think total packaged chips is close to 1,000. One thing I would say though is there was one of the programs that UKRI has run, company called Digital Catapult ran the Technology Access Program. It's where companies applied to use CHERI and try it out in some application of their product. And one of the findings we had is we gave them boxes, they did stuff on them, we sent them instructions on how to send them back to Cambridge if they were done with them and they were just going to go into storage, and no one has sent one back. In fact, some people have specifically said, we have put this in our CI infrastructure, because we found bugs, and in some cases we issued security advisories. Now, CHERI is not meant to be a bug finding tool. CHERI is meant to be a mitigation tool, but nonetheless, it found bugs and it found security critical bugs for people. So yeah, people don't want to give them back, which is sad because we still have some room in the data center. I would say one thing I didn't mention on the slide is that if you're interested in just playing around, you can contact us and we can get you access to a system, or what is the name of the GCC compile farm has access. So any open source developer can request GCC compile farm. Yeah, it is an old machine. We should fix it, but okay. But anyway, we have one that any open source developer can get access to pretty easily. We can give you access. One of the things I forgot to mention in the talk is actually that we have Ruslan and Mark got Beehive ported to CHERI Morello. So we have Beehive support, and we can probably start giving out VMs at some point. Although some fuzzing work is currently crashing the host OS, so there's some work to do. We have not otherwise had problems.
And also, for today, after we're done talking here, you can come bug probably Jessica, or you can bug one of us. And we have a Morello box here. That's the one we gave the presentation on. So we can do quick demos or show you things or run something in GDB if you'd like, and show you kind of what the experience is like.
Yes, Christoph mentions, we have a QEMU as well. Easy way to get access to that is download CHERI build and follow the instructions to build everything. The fact that we can cross-build FreeBSD on Mac OS and Linux is all a product of the work here because we needed it. So we run all our CI, build all our releases, in fact, on Linux.
So by way of testimonial, I played around with that during the Kitchener hackathon and found a number of bugs in PF. None of them sufficiently serious to be security issues, but finding bugs is good. So I'm eagerly awaiting CHERI landing so that we can have CI jobs running our test suite on CHERI, because it will explode in ways that it currently doesn't.
Yeah, and I guess I would say, and I think most of us would agree, that the nice thing about developing on CHERI is that when you write a buffer overflow, you get immediate feedback. Instead of weird data corruption and excitement.
Also, when you're debugging, looking at a pointer and getting how big it is also really nice.
Also one question. So in GNU and in C actually, C99 allows FAM, flexible array member. So that is like you can, in a structure, you can define one array without any size. So, and we have used it in, say, in our Hyper-V drivers. So will CHERI will cause a problem in that type of cases where someone is using a flexible array member?
Flexible arrays are fine. Subobject bounds is fine. I think we understand them. We also understand the degenerate. You put a one length array at the end of your structure case. Can't remember. Are we actually implementing bound it to the rest of the structure? Yeah, okay, so we are implementing a feature where if you take a reference to an array at the end, you get an object bounded to whatever was left.
Okay, so it will not throw an error because it can grow till, like, for that structure, if I have decided, for example, a page for the structure, so that because the flexible array member will be the last attribute of the structure, it can go and reach till the end of the page without creating a corruption for anything next. So,
not quite sure what scenario you're describing.
Like for example, in case of Hyper-V, we have a flexible array member, which we use to store a list of pages which will be passing to the TLB for flushing for the guest address pages. So what we do, because it's a message we pass to Hyper-V, we don't know how many pages will be created. Yep. So we create a flexible array member, and then based on the offsets of the VM offsets, start and end, we decide number of pages, and we fill up that flexible array member without wasting any extra space, because we know that total area we have allocated for the structure which we are passing to the Hyper-V, max can we allow till one page size. So that way we are not wasting memory, and we are allowing a list of pages to be, list of addresses to be sent Hyper-V.
So I believe you're saying that you allocate a page,
yes,
and then you have a variable length array, and you may use part of the page.
Yes.
What CHERI is going to care about is that you allocate a page.
Yes.
So the pointer is going to be page size.
Yes.
Only if you have subobject bounds turned on, and you take a pointer to the array, it will only be the size of, it'll actually be the size of the rest of the page, because it's going to kind of chop off the front, but leave everything else after. But if you're passing a pointer to the struct itself, it's always the whole page, because that's what came back from the malloc that you called.
So because why I'm asking this thing, because if we have to change the drivers because there will be upstreaming. So after the upstreaming, if we have to change the drivers for this kind of for VM changes or PMAP changes, so that will be quite a good amount of work, because we have to also check with Hyper-V teams or the lower level teams whether they will be accepting in that way or not, because of the serialization and deserializations of the things. So
I think you'll be fine in this case. I don't think you'll actually require any changes. Assuming you're actually passing like the whole structure as the pointer you pass to something, then we're not going to do anything with it. And it's going to be the pointer you got from Malik.
Yeah, I will still say do a run on the Hyper-V based systems in ARM.
Well,
ARM and AMD.
Well, we'd have to have a Hyper-V that did CHERI.
I guess Lee Wen can help. Thank you.
Sure. Which actually, it kind of brings up a point that we haven't even talked about, which is firmware. That we currently, it's not a solved problem on Morello even, where the firmware is not pure capability firmware. So it'll be nice, for example, when all the memory safety is in your firmware, not just in your OS kernel, but that's going to take some while to get to. All right, well, I think we're good for today, for this session. And I think I need to check the schedule. What's next? You're at 3, right? Oh, wow, it's 4:30. So what are we supposed to do? So we're supposed to have, oh, I think my schedule is out of date. Let me reload. Okay, so, bug busting is tomorrow. That's right. Okay, so we have a buffer. We were supposed to end at 4. We went 30 minutes over. But I think we actually have kind of free open space for hacking and other things till 5:30, and then we're supposed to kind of start leaving, I think, at 5:30 and head off to whatever dinner you want to have at 6 tonight. So you're now kind of free to spend time either in group discussions or whatever else you'd like to do, but I think we're done with kind of organized talks for at least from the platform for today. Oh yes, and in particular, if you'd like to come up, the Morello box is going to be up here. You can come play with that and ask one of us. But thanks.